Hello. Welcome, friends and dear guests. I'm so glad to meet you here this morning. 2024 RISC-V Taipei Day. In the beginning, let me share this session, RISC-V, more than AI. I am Frankwell Lien. Oh. I got it. Okay. I've been for years talking about the trend of RISC-V. And in the conferences, I've been in Munich, in Japan, in US. I talk to people. RISC-V is one of the three major ISA today. And it is an open standard, and it is a standard. So first thing is that RISC-V has a fastest ever moving ISA in the world. So the penetration of RISC-V is very famous and obvious. The SoC built by RISC-V is forecasted to reach 22% penetration by revenue and the units in year 2030. And the SoC for AI acceleration is projected to reach 53% penetration by 2030. So this is the number forecasted by SHD Group this year. Now, the industry have been adopted RISC-V for many applications, such as application processor, in data center, in cloud computing, in high-performance computing. Also penetrated to 5G, 4G infrastructures for telecom and communications. And also automotive industry, consumer, IoT, AI, machine learning, and the edge application. So in AI, machine learning, we see a lot of world companies, they already adopted RISC-V to promote, to design their chip and promote their product to the users. And application processors on the way is Google Android application. I will cover that a little bit later. And as I said, for data center, cloud, and HPC. For automotive, various kind of applications in automotive industry. And it is a brand new market because EV or new energy vehicle is a kind of a new topic today. Edge computing, security, we will have a panel covering this subject this afternoon. So, talking about the RISC-V, in RISC-V community, we are proud to say RISC-V enables the best processors by several characteristics and advantages. For example, the ISA module, the flexibility, the clean start, no burden for decades, and it brings the flexibility to the engineers that encourage innovation. One example is the RISC-V International Association, RVI, keep design and ratify the specifications and the ISA modules along the way every year. And it is still going on. This slide shows that during 2021 to 2024, and keep going, the important ISA and the specifications for microprocessor systems have been ratified in RVI. I marked the red part for your reference. Those will bring huge influence to the industries and the world. So RISC-V has been trying its effort to lead innovation. We have several terminologies, such as domain-specific extensions, so that in a company, the accumulated knowledge, experience, and domain know-how can be brought to the microsystem designed with RISC-V. And now it is undergoing, RVI is trying its effort to do platform standardization, such as one terminology may be not new, maybe new to you, we call it a profile. For example, RV23, RVA23, that will bring to the brought to you in recent, perhaps in the next quarter. And we keep continuing to build up the culture that everyone do contribution. So you can think about it. In ARM, how many architecture engineers they may have. But I can tell you, in RISC-V community, we have more than 1,000 architecture experts in the world that will keep building this platform, the culture to contribute. Not limited to architecture itself, also hardware, also software, ISA, and so on. Everybody could take benefit, but also after its effort, they will bring the contribution to the world. Yeah, I talked about this in the beginning, so let me skip that. RISC-V is now one of the 3 major ISA standards. So in every RISC-V conferences, people keep talking about the ecosystem it spends effort to build. So we are paying very much effort to building the strongest ecosystem. Today, maybe behind ARM, but one day we will excel. Last year, after pandemic, we came back to have 2023 RISC-V Taipei Day event in physical. Today, we are glad to welcome you to come 2024 RISC-V Taipei Day. This is the slide I'd like to share with you. I call it from RISC-V beachhead to AI and beyond AI. So from this part, this is we call it beachhead. The first place that adopt RISC-V. What is that? Finite state machine control, deeply embedded ASIC, or we call it house control chips. That's the beachhead. Then expand to DSP, vector processor, metric operation, and so on. It is still undergoing today. And also to microcontrollers. And then the next step, application processor. The next step, more AI. So for AI, with different kind of categories of performance from MOPS to TOPS to hundreds of TOPS. We see that many companies in RISC-V community doing their effort to bring big data, unknown algorithms, and statistics in circuit design to do AI devices. No matter it is training or inference. So the hot topics today is generative AI, LLM. Also, in this industry, people are talking about how to do hardware design for generative AI. So today's conference, we have many speakers. They are strong in this field. They will share their product, their knowledge with us. And what is AI computing power? I borrow a couple slides from NVIDIA to talk about that. In NVIDIA, they figured out AI is the way back to 2007. So it is 2024 today. Think about it. If your company, your institute just touched AI for less than 20 years, less than 10 years, 5 years, then don't worry, you have a long way to go. You have to take effort to study AI. For example, NVIDIA today, they are selling computing power by AI. They tell you, but like I said, in year 2007, they figure out AI is their future. So they pay effort. And look at that. In 2024, they reached so high achievement. So computing power can be, for AI, can be stacked, can be accumulated, can be designed. This is the secret for RISC-V that can be applied in AI. And we are honored to watch the presentations from today's speakers, from our sponsors, from our invited guests, that they will do RISC-V aggressively. Besides, I also like to share, in fact, NVIDIA is one of the board director in RISC-V board meeting, and they have been quietly adopted RISC-V in their chip design. So it's been back to, several years ago, like 7 years, they started to do that in GPU, in NVIDIA's offering of AI and the GPU. RISC-V is there. Another example is Meta. Meta has been shared their first generation and second generation of their processing element inside their first generation own architecture chip for AI server in their data centers, adopting RISC-V. So if you use Facebook or Meta's others application, app, in your mobile phone, then you use RISC-V to calculate, to compute the data stream every day. Last but not the least, I'd like to tell you that RISC-V is strong, or say strongest competitor to ARM. We have many pioneers promoting applications, AI included, but not limited to AI. There are more, like IoT, like 5G, data center, automotive, many applications. We have pioneers that are aggressively promoting and using RISC-V and deliver their product and solution to the world. So I like to conclude my presentation that RISC-V era is coming. It comes with AI and much more. So with today's conference, we also have one subject we like to share with you and help us in future. That is, we should work to promote RISC-V to Taiwan's IT, OEM, ODM industries downstream to the value chain, because that will help everybody here to make profit if you are enterprises, to help you to promote your institute or universities. Okay, that's my presentation. Thank you.
What a wonderful opening from Mr. Frankwell Lien, the chairman of RISC-V Taiwan Alliance and chairman and CEO of Endes Technology. Thank you very much, Mr. Frankwell. Now, welcome to Reshape the Future with AI Taipei Day RISC-V 2024. And my name is Laras. I will be your host today. On behalf of the organizer, we would like to say thank you for every one of you that come today. Now, this year marks the very first RISC-V Taipei Day in Hsinchu. So we're thrilled to see so many of you coming all the way to come here. Thank you very much. Now, in 2024, AI has become the very hottest topic. And so with the AI advancements, the open source architecture of RISC-V has become the vocal point of the empower AI and to drive a new revolution in AI computing. Now, today, let's join a lot of speakers coming all the way from local and international. Thank you very much. And we want to see how RISC-V open source processor architecture empower complex IC system and AI computing architecture. Now, first and foremost, I would like to invite Dr. Alex Wang, the chairman of Taiwan IoT Technology and Industry Association, to see and say some few words. Please welcome Dr. Alex Wang.
Good morning, everyone. I'd like to first welcome the attendance from the government representative, Director Tai Dongping. He's from Ministry of Economic Affairs, and of course, Mr. Frankwell Lien, chairman of the RISC-V Taiwan Alliance, and then Mr. Lu Dai, who is board chair of RISC-V International. As chairman of Taiwan's IoT Technology and Industry Association, it's my privilege to welcome everyone here. And it's a fond memory. About 5 years ago, I believe TWIOTA, that's our association, was the first industry association to recognize the potential of RISC-V. Actually, by that time, RISC-V was just making its significance, but nothing compared with today. Because to a lot of people, it sounded like a startup. And however, we recognize processors is like a crown jewels. It's on top of the food chain of the semiconductors. It's the most valuable and perhaps most difficult At that time, ARM was very well established. Of course, 86 series as well. And we believe at that time RISC-V is the future to come. And therefore, TWIoTA takes some great strides, I think, to establish the RISC-V Taiwan Alliance. I was honored to serve as the first chairman, and it was not a trivial job to begin with, because most people probably hear about it, RISC-V, but they hear a lot of other things as well. And so after all this years' effort, I'm very pleased to witness the progress made over the government and the industry support, and especially under Mr. Lien, the leadership. I think the Taiwan RISC-V Alliance also make a good participation and also contribution to the RISC-V International. Today's theme is reshape the future with AI. I think everybody hear AI these days. AI is everywhere. And especially, of course, the generative, the new wave of training and inference, semiconductor use in the generative AI like LLM. And recently, I think on the edge, the AI so far has been mostly on the cloud. But on the edge, we also start to see a lot of discussion about the AI PC and the AI smartphone. I think yesterday, the one you hear announcement from Apple i16 and the Huawei XT, those are all have an NPU with some AI capabilities. And it will be so pervasive, it's everywhere. But the question is, how do we take advantage of it? And today's theme is to expand on our role and the development, and hopefully everybody will catch some interesting points. And to me, it's almost like a celebration event, because we started up the Taiwan Alliance, and now we see a good audience with individual talents and capabilities. So I take this opportunity to welcome everyone, and I'm pretty sure you will enjoy the program today, and I wish you the best of success. Thank you.
Thank you so much, Dr. Alex Wang, for your encouragement. Please remain on the stage. And we would like to invite our honorable guests and to have a picture together. Please call the following honored guests to please step forward on the stage. Mr. Frankwell Lien, RISC-V Taiwan Alliance. Mr. Lu Dai, RISC-V International. Mr. Chen Tai-shi, Tech THY. Mr. Emil, Invest Taiwan. Mr. Chongping Sai, Industrial Development Bureau, Ministry of Economic Affairs. Dr. J.S. Huang, RISC-V Taiwan Alliance, and Dr. Tien-Fu Chen, RISC-V Taiwan Alliance. Please step forward. All right, please make sure that you have a big smile. Okay, and a big thumbs up. Let's take a picture in 3, 2, 1. Okay, now for the final pose, we will have a V on your right hand. V as a RISC Taipei Day. Okay, RISC-V, all right. V, okay, perfect. Now on the count of 3, 2, 1. Okay, thank you very much, gentlemen. Mr. Frankwell and Lu Dai, please stay on the stage. Okay, Mr. Frankwell and Mr. Lu Dai, please stay on the stage. And we would like to invite our lineup and remarkable speaker from domestic and international. Please come forward, Dr. Charlie Su, Andes Technology, Mr. Wei-Han Lien from Tenstorrent, Mr. Mark Hayter from Rivos, Ms. Barna Ibrahim from RISC Project, Mr. MIcrochip, Chalvis Quantum, Mr. Ted Speers, MIcrochip Technology, and Mr. Lanier from Ventana Microsystem. Okay, please come to the middle and have your biggest smile and big thumbs up. Okay. Big thumbs ups for Taiwan. Okay, please see, and 3, 2, 1. Okay, on behalf of RISC-V Taipei, please put the V on your right hand. Okay. V, okay. Victory, 3, 2, 1. All right, thank you very much, ladies and gentlemen. Mr. Frankwell and Mr. Lu Dai, please stay on the stage for one more time. We have a lot of pictures today. Now, I would like to invite our most supportive force of RISC-V Taiwan Alliance executive members. Please come to the stage. Dr. Chen Li, Professor of Department of Computer Science, National Tsinghua University. Dr. Ryan Chen from MediaTek. Jun Ming Lu from Electronics and Optoelectronics System Research Lab E3, Mr. Ted Chang, Spokesperson and Special Assistant Andes Technology, and Dr. Kai-Si Lu from Sky Miser. All right, please come forward on the stage. Have your big smile and big thumbs up. Okay, please put your, okay. Thumbs up, a big thumbs up. A little bit on the center. Thank you very much. Oh, okay. Perfect. And smile, 3, 2, 1. Okay, one more time with V as RISC-V and victory. In 3, 2, 1. Thank you. All right. All right, thank you, gentlemen. You may go and proceed to the seat. Okay, we have a lot of pictures. And we also would like to welcome another warm support from RISC-V International. It's an honor to have our board chair of RISC-V International that made a special visit to Taiwan. Ladies and gentlemen, please welcome Mr. Lu Dai.
All right, thank you. Welcome everyone to the RISC-V Taipei Day. I'm Lu Dai. I'm the chairman of the board for RISC-V International. Today's topic is all AI themed, so I have put together a short slide deck for AI. But a lot of the information, you probably have heard that before. My focus is to talk about why RISC-V is a good fit for AI. If you feel some of the information is redundant, then we have done our job. We have convinced you it is a good fit. So let's see. Well, what is RISC-V? I think everybody here should already know what is RISC-V, but one thing I want to point out is RISC-V being the V, the 5, is because RISC has been the ISA all established ISA. So it came from a long history of the famous computing pioneers. So all the way go back to the MIPS, Spark, and all those processors, including our friendly ARM is also based on RISC. RISC-V is merely the latest iteration of this architecture and the latest and greatest. So for RISC-V International, I just want to briefly talk about our organization. This is a international standards organization. We have a lot of members, both from the industry side, the academia side, as well as individual members. Our membership has been growing like crazy. Every year you saw more and more members joining, and we are actually having trouble to keep this slide up to date. All the time we need to go back to see, every conference we need to see if the number is still correct, because it's keep on adding. We also have a strong ecosystem. We have all the softwares, the boards, the tool chains. So this is kind of like an eye chart, but you can actually see this chart on our RISC-V International website, and also listed a lot of those companies that are providing the hardware as well. So it might be hard for you to actually zoom in to see this thing, but it is available on our website as well. Talking about AI, I just thought it might be a little bit interesting to see what is AI defined by asking ChatGPT. So I just copied down what ChatGPT said what AI is. But of course, just like any AI Q&A, if you go to ChatGPT right now, they probably give you a different answer because if so many people ask for it. One thing that kind of want to point out what is AI is, it does need to create a system that provide a task that typical human beings is doing, but the machines is going to be able to do better. But this also includes a very specific task, and the task that needs a specialized skill. And from that perspective, if you look at some of the typical AI algorithm, you have the custom automation that nowadays, because AI is so hot, people say they have the AI capability. And a lot of times I look at it is, they have the capability before. It's just, it used to be called automation, and now it's called AI. But they are also what I consider it's more authentic AI, that you actually has a specific machine learning algorithm behind it. And those are not your typical pro regular expression comparison, that kind of things that people also call that AI. But a lot of those AI algorithms, they also have their own custom recipes. So different AI software companies, different vendors, they provide a specialization in their algorithm. So that presents a challenge that the AI software vendors, they would like to have their own hardware so that it can both make their software work better as well as protect some of the intellectual properties of their software algorithm. So here is why the RISC-V could fit in, but just some typical example. I mean, the most famous one is the OpenAI, ChatGPT, and the NVIDIA front. But one thing I want to point out is part of NVIDIA's success is actually their CUDA software ecosystem. So just keep that in mind. But coming back to the hardware side, why we say RISC-V is fit for AI, is the best fit for AI. I think Frankwell in his opening remarks already talked about RISC-V as a standard. It is an open standard. It is a single standard that we can all be compliant to it, and it's also an international standard, so you have access. But from a technical perspective, RISC-V as an ISA from the very beginning when it was developed as a customizable ISA. Frankwell mentioned all the extensions. So those custom extensions allow you to have a base ISA that you can have the compatibility across a whole slew of hardware vendors, but you also allow a custom extensions that has to handle the specialized capability. And within the custom extensions, there's a difference between an approved extension by the standards body versus a custom extension by the vendor themselves. So that approach allows the AI vendors to produce a hardware which has a baseline compatibility across all RISC-V, but also have some special tweaks that is special for their particular customers and algorithms, so they can show their differentiations. Now, that is extremely important in the area of AI, because there's so many AI vendors, the AI software providers, they're looking into making hardware, or they are getting custom hardware, mainly because they want to show differentiation. And RISC-V as an ISA from the very beginning, it was designed for a custom accelerator. Now, going back, now we can say that RISC-V is designed for AI, but in reality, when we started RISC-V ISA, we were not really thinking about AI, but we were thinking about having RISC-V ISA to be more applicable for a custom accelerator. So AI is just one of the custom accelerator. It's not on these slides, but I just want to briefly mention from the RISC-V International's board, we actually, from technology perspective, identified a few areas for us to prioritize on. AI is definitely one of them. The other one is automotive, and then the third one is security. Now, if you look at AI and automotive, it's both a very, very hot market. There's a lot of demand, there's a high growth there. But if you look at AI and security, both of them actually fits our custom extension very well. AI, you need the custom algorithm that the hardware, software, working together. For security, there's a lot of custom security algorithm that might be demanded by different regional governments. A lot of countries' government, they want their own country security chip to implement some special algorithm for their own purpose. So that's also a very good fit for RISC-V. So coming back, it is because of it's a custom, it's a special fit for a custom accelerator. Now, also because RISC-V is a very new ISA, its adoption is expanding very fast. For AI being the new child on the block, and everybody is wanting to get into it, RISC-V being a new ISA allows us to include the latest technology in our baseline. I think we shared those slides before in Frankwell's opening as well. One thing I want to point out is these slides are from this group called SHD. They do the market analysis. You may not believe the numbers, how accurate that is, but one thing about the market analysis is look at the trend. Don't look at the exact numbers, but the trend you can see, RISC-V is definitely growing. And if you look at the different bar charts, I think it's hard to see the actual difference, but I can tell you the highest bar is AI. Now, if you look at the other slide where we're talking about, so this is talking about, I believe it's the percentage market shipment. Yeah, so it sees from a growth perspective, AI also, again, has the highest growth. I believe I have another slide. Yeah, so this slide is talking about market penetration. So it's very interesting to see, not only RISC-V is growing the fastest, but if you look at the bar on the left-hand side, you see the green bar, the high green bar, it is actually the AI. And then the next step, there's a red bar, also is very high. It actually is automotive. So you can see those are the two areas that have the highest growth. But if you look at the penetration perspective, the estimate is AI penetration for RISC-V, that by 2030, more than 50% of the AI chip will be powered by RISC-V. So just keep that in mind. This is one of the things that we are looking at it. Just to kind of wrap it up, because we are the newest technology that allows us to include all the latest and greatest because of the openness. We are all talking about AI as the technology that we want to let everybody have access as an open international standards. That's also a good fit for it. Our technical aspect of the RISC-V, the modularity fits AI very well, and we have a worldwide ecosystem. And so, RISC-V, we have an ecosystem, we have a great ISA, and we'd like to welcome all your partnerships and your innovations. We go from a technology development, now goes into a commercial adoptions. And let's bridge the gap from the technology to commercial, and let's not lose sight of our end customers. And that's why we want to see everybody to not only looking at the technology side, but thinking about what your customer needs, and let's work together. Thank you.
Thank you so much, Mr. Lu Dai. You may go ahead and proceed to your seat. Now we would like to invite Dr. Charlie Su, the President and CTO of Andes Technology. You may go ahead and proceed to the stage. Thank you very much. Please welcome Dr. Charlie Su.
Hello, everyone. So another AI subject. So today I'm going to talk about RISC-V solution for AI and machine learning, not just for the data center, but also for the edge and endpoint. So like Lu just showed a number. So the market research data for RISC-V by SHD group. So I think we focus on the ratio. So this is about RISC-V SoC market. So it's grow almost 3x last year. And for the next coming 6 years, going to go another 16x with a CAGR for the almost 50%. So among them, I want to share with you, they also point out for last year, and this had over 30% of the market share of RISC-V IP shipment. So we had customers ship into a mobile space, MPU, MCU, AIoT, and all kinds of flash storage, 5G networking, and also auto-grade SoC with our certified automotive processors. And last but the most is large-scale AI machine learning, where we have the largest customer working on this area, which we're going to talk into more detail. So first, Meta Training and Inference Accelerator, MTI first generation. They revealed it last year in an academic conference, where the two important processors in the PE subsystem using our early generation of NX27 vector processor, use that to control their AI subsystem with all kind of accelerator. So the important thing we offer is that automated custom extension allow them to create new interfaces, new register, and wrap that with new instruction. So their AI compiler can directly control through our processor to their hardware accelerator. And all this, also we generate automatic file so to enable their LLVM compiler. So this year, just about a month ago in Hardchip, they revealed a new generation, MTIA, and it's already served in their production on the Facebook, Instagram, and so on. So you look at two generations of block diagram, it look alike, right? Even though they didn't say which RISC-V code they are using. And in addition to the Meta, so RISC-V, through us, we enable a lot of innovation on large scale AI ML. They based on our vector processor, NX27V and X45 MPV, and also our auto-order processor, X65, and also simpler, smaller processor, X25. But they all come with this automated custom extension, allow them to add instruction to connect to their hardware accelerator. So here's a couple examples. So we have customer working on their AI accelerator using SRAM-based computing memory, like Axera in Europe, and Ren AI and Tenstorrent in the US, and also Homo in China. And we have customers using AI accelerator, using photonic to implement their AI accelerator, like Intelligence. Also, AI accelerator for the cloud service, like Sapien. Recently, they merged with another Korean company. Both are Korean companies, but they merged together, getting bigger. And we also have customers using AI accelerator for others. So based on that, we know that even though most of the spotlight is in AI on the cloud, but edge AI actually is bigger. So to give a couple examples for the edge AI ML application, or so-called on-device intelligence. So they are intelligence edge server with specific domain knowledge, like legal, medical, even the enterprise HR information. Or smart factory, healthcare, transportation, where AI can use to monitor or doing a predictive maintenance. Or networking system for the enhancement of performance, security, and traffic management. And also ADAS, self-driving vehicles, surveillance, robots, and so on. So there's plenty of opportunity there. So what does RISC-V have to offer for AI ML application? So first, in AI ML application, there's a lot of computation, so we want to accelerate, so it can be done in the real speed. The major one is metric multiplication. So in CNN, it takes about 80% of computation, but even in the latest popular transformer and LLM, it takes about 50%, so it's a big chunk we want to accelerate. So there are hardwire solution, or kind of hardwire solution. They're probably most efficient and powerful, but it is metric. You turn that into the instruction form to become most flexible, so easier for software, especially AI compiler, to control it. So for that, RISC-V had two task groups working on two different kinds of vector instruction. One is integrated metric extension, which leverage existing vector infrastructure, and also attached metric extension, which is kind of independent of the core. It's a little bit more like hardware solution. You can sit on the bus. So the next one is there's a bunch of nonlinear activation function keep coming as the algorithm, new algorithm come up, like softmax, sigmoid, Hayter, and so on. So those are most suitable for custom instruction, because I doubt any architecture would make that become a standard instruction. And it's happened to come into the RISC-V's strengths, where we have custom extension, extensibility, allow people to bring their innovation there. And last but not least, so remaining there's still a lot of remaining parallelism with smaller, less structural. So for that, RISC-V has a full blown of basic computation, but you can have very wide width, vector extension. And also for smaller parallelism in the endpoint, we have SIMD, DSP, P extension. So they are there to catch all and provide future proof. So this is kind of technology-wise. But also very important, I think the previous speaker also mentioned that ecosystem for AI framework and also application framework is very important. RISC-V as a standard, it basically attracts fast-growing open source and also commercial support there. And the RISC-V itself, we provide a profile like RVA 2022, now 23 is almost there, even though this is 2024 already. But that profile basically provide, reduce the variation in terms of different RISC-V extension and also consolidate the ecosystem efforts. So here I want to introduce you Endless Air, or Endless AI runs everywhere, which is the end-to-end AI ML solution, which Endless provide. So on the top, you can take AI or NN model and all the way down to SQ on your hardware. So we're going to talk about the detail later in later slides. But in addition to those, we also, whole solution will also provide generic tool there, like our NSID, pipeline optimizer viewer, and also ACE Copilot tool. So first, let's look at this vector processor family. So X25V100 and X27V is the first generation vector processor used by Meta. So it based on simple 5-stage single issue pipeline and can have a vector width and also the computation produced by one instruction up to 512 bits. So, and new generation, the X45 MPV is our hardest selling vector processor today. It's based on 5-stage dual issue with 8 core per cluster. It provides high-speed vector, local memory, and also, in addition to our popular ACE for custom extension, it actually provides ACE for RVV, which is allow custom to adding the custom vector instruction to optimize their workload. And we also support the full arithmetic instruction for bflow 16 and has vector length and vector computation, D length, up to 1024 bits. And we are working on next generation already. So it's X46 MPV, which we're working on the integrated metric extension, which is one of the standard that RISC-V is working on. And we extend the 8 core per cluster to 16 core per cluster, and also private L1, L2 cache. ACE for RVV going to continue to enhance. At the same time, our vector width go to 2K bits. And there are 47 MPV. So we're going to provide more feature like CHI-based cluster coherency, latest RVA standard, and more floating-point format like FP8, FP4, and so on. So I want to give an example of how customers use our ACE with automated extension. And this presentation is done by RAN AI in Andes RISC-V Con in San Jose the past June. So they basically using the ACE RVB to basically generate another function unit inside our vector processor pipeline. So it's basically very natural. They don't need to know too much about our vector processor. They just focus on their computation. So they can. So what they do is they in the talk they present how they do sigmoid instruction, the vector instruction. And in their SoC, they actually also adding softmax, SILU, and other ACE instruction to help speed up their workload. And what's important in our ACE framework is that with our compiler tool, RTL, compiler, and systems simulator would automatically update it depending on what kind of update they made to their instruction definition. And next, I want to talk about this application processor family, because when you run AI workload, other than just computation, there's a lot of application level control you need to do. So this first is our X60 series. The X65 is our current product, which is based on RVA 22 Plus. It's 13-stage all-the-order execution, multi-core cache coherency, Lien is capable up to 8 core per cluster. And we already have customers using it. And we are working on X66, which is 20% higher performance and going to support RVA 23. And this is a superset of so-called Android base, which including vector, vector crypto, hypervisor, and so on. And one thing that we particularly added, most important for X66, is the vector processor, which has 2 pipelines and they share with a 14-point. You can execute any 2 ALU vector instruction and 2 load or 2 store. So we're going to have provide plenty of performance boost there. And beyond that, we're already looking into X67, which is going to bring another like 10% performance there and going to catch the latest RISC-V standard there. And we reserve a spot called X63, which is a power optimized version because some customers may not need that much high performance of 4-way superscalar, and they probably need 3-way or 2-way, but power is more important there. So it's kind of custom-driven spot. And in parallel, we have another project called Cusco, which is development in parallel by a different team. So it's a 14-stage, 6-way or 8-way out-of-order processor with our patented time-based scheduling. So the feature-wise is very similar, but microarchitecture is very different. So the performance can go up to another like 50% to 2x of our 67 series. Okay, so we talk about different our application processor core or vector processor core, and customers may have their own hardware accelerator. So there are a couple of different ways to put together compute subsystem in AI SoC, depending on where your trade-off point. For example, you can have application core with small vector, and you have a large vector core, and with a long vector VLAN, and you have our hardware accelerator for matrix multiplication. And it's up to customer. You can use ACE to kind of instructionalize those computation. And you can also have the more and bigger application processor core with wider vector and get rid of that vector. So that's another option, but your performance may drop a little bit because the SoC one, the left one, is very fully optimized for particular workload. And going forward, since now a processor with the metric instruction, you can include vector computation. So you may want to, in some application, you may want to get rid of the hardware accelerator altogether. So first you may suck into the vector core, so that one scenario, or you can suck that in all the way into just one type of application processor, which with shootable VLAN and with metric multiplication, and also ACE-RVB to adding the instruction for the nonlinear function, for example. And different form has different implication in terms of the attribute on the left. So, for example, you have just one application processor. It provides probably the best programmability, because the general purpose is just one kind of processor you need to program. But your performance may be lower because you don't fit everything. But the other extreme is you have different hardware and you can fit your application very tightly. But this is kind of the option or the choice of the SoC design. So we provide all the options for customers to do. So, and this AI software. So it's on top, basically we can take the model and go through our NM pilot to do the graph level optimization, such as pruning and quantization, and they do the backend optimization there. And bunch there. And within it, there's AI compiler, there's library, and so on. So for example, in the AI compiler trend, there's LVM, which can auto-vectorize the IR generated by IRIS or TVM. So those are open source compiler. And the IRIS itself can take microkernel optimized with RVV instruction or even ACE-RVV instruction. So this is optimization can be done by per processor. So we do a lot of work here on the microkernel. And also, and this invented auto IRI, which is basically the flow to find the better tiling efficiently instead of user can try it by hand. And with our experiment, you can achieve over 2x performance improvement over just using plain IRI. Here we have example done by vector length of 512 bits and 1024 bits, and using 3 different AI models. And in the library part, so we have NN library, which is proprietary by NDIS, mostly focused on MCU part. And you can take the kind the used by the template generated by the NN pilot. So it's over 200 functions there, so it's quite coverage. But we continue to evolve to take the latest the models to support different operator. And they also back up by more general purpose vector and also DSP library, which has over almost around the 400 of them. And then the open source based NN XNN pack. It has about 200 high-level functions and support PyTorch and TensorFlow Lite. There's a lot of functions which need to optimize and can be optimized using the standard RISC-V RVV instruction. It's just that there's more function that we can continue to optimize as a RISC-V community. So the key takeaway today is that RISC-V has been used in AI, machine learning, basically from cloud to the edge. And RISC-V advantage is in the mature and scalable vector instruction and upcoming metric extension. And with extensibility, RISC-V can allow customers to add in custom instruction. And this not only just offer the signal interface for customers to do the work. We automate basically everything you need to do related to processor, other than the function yourself that you need to decide. And RISC-V, the open standard, basically enable fast-growing software ecosystem. I think the RISC-V profile will further consolidate the effort and speed and make RISC-V run even faster. So, and this offer for machine learning, I think we have a couple things. The end-to-end software tool with NDIS optimization, and also in the efficient vector core in our 40 series processor, and also powerful linear core 60 series and Cusco series. So if those are not what you need, NDIS has over 30 RISC-V core to help customer to complete the last piece of puzzle. So to just give an example, We just announced a PR probably about 30 minutes ago with Rivos. So the title is that Rivos select this NX45 for control function in upcoming high-performance RISC-V SoC. And the subtitle is NX45 become the only RISC-V core to pass Rivos' rigorous verification process after extensive evaluation of leading RISC-V cores. So thanks Rivos for selecting this, and wish you guys good success. Thank you.
Thank you so much, Mr. Ludai, for your wonderful sharing. You might please be seated. Now, we also would like to invite Mr. Wei-Han Lien from Chief CPU Architect and Senior Fellow Architecture of Tenstorrent. You may go ahead and start, Mr. Lien. The floor is yours. Thank you.
Hello, everyone. My name is Wei-Han Lien, 电伟汉，我台湾生的，所以 I'm really glad back to Taiwan. So definitely ask me like if I want to sponsor RISC-V Taipei. I said for sure, why not? It's my hometown, right? So today I'm going to talk about the empower AI innovation with a versatile and open source RISC-V processor. So versatility actually coming from this open source standard as well. So it's actually tightly coupled together in terms of its property. So I will talk about that. So this is exciting period of the time in the human history, right? So my wife asked me why I work so long, why I'm so enthusiastic about what I'm working. So my career has been working on x86 early on when I graduated from school, and then I'm working on Apple, iPhone, iPad phone chips, right? I've been working there for 13 years. And then all of this product is actually great, right? iPhone is revolutionary thing, but this is bigger, even bigger. I just tell my wife saying that this is an interesting human history of the time that 100 years later, people will identify this as a new industrial age where the machine intelligence replaces the human intellect. It's how important that is, right? So AI will change everything we are doing in the next 10 years, right? From how we do business, how we interact with the people, and how we actually live, right? The one special attribute of the AI is actually coming from this personalization, right? So what it does is actually allow the technology create this intimacy to you in terms of usage of the technology. So you can personalize your drug when you have a disease. You can personalize what your kids learn in the classes, right? Based on their level and their interest. So this personalization, right, requires tons of compute, right? So this is why today everybody is trying to do solving this computation problem, because the coupling of the computation requirement and also the personalization, there's a 50 billion of the people, is tremendous amount of computation requirement. So what is, so to do this customized digital transformation I just talked about through the AI, so what I want to talk about is, so what exactly is the computation requirement? You can see in this chart, right? I've been showing this many times. I find it interesting is that since 2012, the AI complexity computation requirement is characterized by its model parameter size has been doubled every 3 months, right? So this exponential growth on the computation need, and this coupling also about the computation data generated by the human race every day is 2.5 quadrillion bytes per day. This collide together generated the perfect storm for the computation requirement in the AI. Right? So our view, my view of this solving this computation problem requirement is that you have to go through AI computation everywhere. That means the computation hierarchy, right, you are using daily, which I will present next, is required to be doing all the level of different AI you have. So the AI revolution, right, has to be pervasive in terms of computation. That means on the client device, right, on the edge device, on the data center, you all need AI, but it's impossible to send all the data to the data center. The computation has to be distributed, right, separated, partitioned, enable the efficient access. Right? I constantly giving this analogy about Like if the human body actually send all the neuron signal from the body to your brain, your neuron will be so big that it's impossible to handle that efficiently in terms of transmission. Human being is the most power efficient processing engine in the world. 100,000 years, millions of years optimize how you actually operate, give you the best actually power efficiency, right? So it's a distributed processing. Right? So that's why Tenstorrent is building this we call scalable technology, enable you to build the computation, AI computation, all the way from client device to the computation hierarchy to the data center. Right? So this is kind of demonstrating this picture here. Right? So the key component we are actually building, the scalable technology is the CPU, right, which is based on the RISC-V. We're building high performance scalable RISC-V technology. And then we also have scalable AI. And to further that, we actually now start building the chip test system so you can have this flexibility on the composition and also scalability in terms of computation. So now we got to the main topic, right? So you understand that the computation requirement that we need to have the scalable computation to address the AI computation. And then why the RISC-V is actually very suitable for addressing this need. Right, so you look on RISC-V, it's an open standard. The open standard actually creates versatility, right? You need it for addressing the AI compute. Like I mentioned, the AIs have to be compute on all the compute hierarchy you use every day. So RISC-V has this scalability, right? So you can basically, without license, building any arbitrary PPA performance level, big, small processor need for AI processing in different level, right? Secondly is that extensibility is that vertically, you're building a processor in a particular element, you're able to extend the ISA semantics to support, to accelerate particular function you're actually interested in doing, right? So that's the flexible extensibility horizontally, right? Efficiency, from my perspective, I've been working on 4 different ISA. RISC-V coming later. In general, it has less historical baggage in terms of ISA support to support the compatibility. So you will be able to building a little bit more efficient processing, computation. And last one is actually the stability. I think this is very important as well, right? What I mean stable is that the user of the technology can choose whatever vendor or building their own technology by themselves, right? So the stable supply of technology is important for this very ever-changing industry because the demand is so dynamic, right? So you need a lot of vendors supplying the solution you have. And also, if you have the capability like Tenstorrent, we are building our own solution to supporting the AI. So this 4 properties is actually very, very important why there are so many companies choosing the RISC-V, right, to supporting their AI. I think the open standard actually enable this wide variety of the product you actually can build. So that's a good thing. So Tenstorrent RISC-V technology have been working with the ecosystem partner, right? So we are going after, so you look on our ecosystem, our partner, right? We can go to auto space, we can go to data center. We are primarily focused on the company, focused on the data center. We also have a client partnership. So it manifests itself, the technology we are building, the scalable technology is actually going to all level computation hierarchy we're using every day. And then talk about the ecosystem, the potential of the supply chain issue that the other company using like ARM architecture, x86 architecture, right? So you have more than 10, 20, or even 30 companies provide the RISC-V IP now. This stability of the supply chain, right? One company ceases to use this, or you go for the better option, right? It's such a wonderful thing for building the AI computer. So back to, before I dive in, actually how Tenstorrent using the RISC-V for our AI technology, I want to give you a little bit background on our product so you understand it. Company is leading by legendary architect Gene Keller, right? So if you know Gene Keller, he's been working on digital alpha. He has been in Apple creating the A-series processor, in AMD inventing Zen, in Tesla inventing the Hardware 3, right? Autonomous driving system, he started that. So now he's our CEO, right? I've been having a working relationship for him for 20 years. The 3 technology we are keep building is that we have to sharply focus on data center technology, competing with NVIDIA, right? So we are building AI technology, right, based on our Tensix IP, and then we're also building the Ascon CPU, high-performance CPU, 18 to 20 spec in processor, right? And then using that technology for building a heterogeneous computing system. Of course, the AI is tremendously important in terms of the software stack. So we have the Medallion stack and Buddha stack, right? So that's the two stack we have. And then we use the technology, we also license our technology, right? The key important thing to win this AI war with this NVIDIA big giant is actually cooperation among the industry, right? With the open standard, open source. So Tenstorrent is interesting. We open source our AI software stack everywhere. You can download it, play with it, right? And then we also plan maybe in the future open our hardware standard as well. And then RISC-V processor we're building is already standard, and the ecosystem we're actually building a chiplet ecosystem, right? It's also very, very good. That's why we can address our product with the data center, with the autonomous industry, and then client device. So this is the company actually has a partnership engagement with us, ranging from multi-super billion-dollar like Samsung, LG, Hynix, right? All this company and Hyundai, right? And also like Bosch, right? All the company we're actually involved in is actually like our technology because it's open and it's also addressing the computation need in the AI market. So kind of re-talk about it, right? So we have two IP, one is high-performance RISC-V, one is Tensix IP is a fundamental building block, scalable building block for our AI architecture, right? We have an AI chip that we're building the chiplet technology. We're going to tape out, Q1 next year, we're going to tape out many, many different chiplets so that we can compose them together. And then we're also building our own server as well, right? So we're building a server box, which is contain 32 of the AI accelerator competing with DGX, right? In NVIDIA offering, right? We also have all open source software, right? Software is tremendously important. We are open source, we are collecting, we are having our partner co-developing the software stack. So this is our roadmap, right? So giving just briefly overview our roadmap, right? So we already have a Grayskull, we have Wang is actually selling, right? So we're building workstation, we're building data center box, then Blackhole is being bring up, right? We'll be shipping end of the year based on TSMC and N6 technology. It's also the first technology actually having the heterogeneous compute. That's going to have an AI accelerator. We also have a general purpose compute in a one single die. So I'm leading the next generation definition on Cogrando, right? So it's a chiplet ecosystem. So you have the Quasar, which is our next generation AI computation die, and also the Aegis, which is the next generation high performance CPU server, right? So based on the RISC-V architecture. So all this two technology can compose together in any kind of configuration, right? To address the computation need in the data center. So we have two software stack. Buddha is a software stack, it's a compiler driven. So you can write PyTorch, you compile and map to the hardware, right? So it's an automatic flow, easier for developers not familiar with the software stack, right? And write it and want to test the algorithm correctness, right? Less performant, but we also have the Medallion flow, which is basically the bottom-up approach, right? Based on the library, you can customize it. If you're familiar with the hardware, right, you can super optimize it. So how we actually, so I gave you a kind of a brief technology roadmap introduction about Tenstorrent technology. So I want to talk about how we exactly using the RISC-V open standard processor, right, in our technology. So you can see that on the right, on the left-hand side is our IP. So you can see that little T element we call Tensix. It's actually the basic building block for our AI accelerator. Inside that Tensix, right, we can use a lot of Tensix, compose it together to building a larger AI compute, right? So you connect to the NOC, right? The NOC topology can everything you choose, whatever you choose to build. But in our case, we build in mesh, right? So mesh topology, 2D mesh technology. So we're using the IP, we can instantiate it, we can sell to the people, and we have partner instantiate in there like television, for example, right? And using our IP. But also we instantiate a lot and building the chiplet, right, for the next generation. So it contains many Tensix in there and connect to the mesh and forming a computation, basic computation platform. Then we take the chiplet and compose it together and make it even bigger compute, right? Putting it in a package. So this is a scalable architecture. Like I mentioned, it's very important for you when you address the computation need in AI, you have the scalable solution because the computation has to happen everywhere, right? And then in our system chip that has a scalable technology based on the Ethernet, so you can connect multiple of them, forming this we call Galaxy box, is using to competing with the NVIDIA GDX box. So this is how we actually has the scalable solution, all of it one tiny 10-6 element, putting in IP, embedded IoT space, or going to all the way to data center. Right, so this is just a logical view, right? So you can see the 10-6 there, right? That's a building block. Right, there's a tiny little RISC-V processor where I explain to you how we actually use them and compose them into the NOC and then forming a larger compute, and eventually we use that using the Ethernet, technology to expand it, doing the scale and scale up. And then we can build in this Galaxy box. In each of the boxes here, you see in the middle, it's actually 32 processors in there, right? So we can use that and connect them and then forming even a larger compute. So this scalable 10-6 element here, you can see that there's two distinct elements. One is the communication on the left-hand right-hand side, using to receive the data, right? In the middle, there's a computation units to issue the instruction to the matrix engine. So it's a specialized MIMD, multi-instruction, multi-data stream, distributed processing. And coordination is through the RISC-V standard instruction, right, to lock in the semantics to communicate each cell. It's like a multi-MPI interface, right? So in the middle, there's the processor is responsible for issue the instruction, manage the traffic, going to the scratch-by memory, right? So you can issue the instruction to the vector and matrix engine. And then in the middle, in the two on the side, is basically RISC-V processor using to packing and unpacking the data, sending from the NOC. And we also have a distinct communication subsystem using for managing NOC, receiving the package, right? And managing the FIFO on the input and output side, and communicate with the other 10-6 unit, right? Through the NOC in the other computation area. So the process I just talked about, the usage is many very small embedded processor, right? They have specialized function, they have a special usage, they are dedicated to one with the work. They can potentially using for general purpose compute, like sometimes we call in-packet, in-communication compute. But in general, that's not the primary usage because they're less efficient in terms of its computation capability, right? However, it's a really good control process to control how you issue instruction to the accelerator. And we are building this high-performance CPU, which you see there. We're in the process of the taping out. The Q1 will tape out, and this is running great in emulation. We are performance correlated at the 18 spec-in. We plan to going up to 20 spec-in per gigahertz. So if anyone interested to license this core, let me know. Yeah. And then we plan to use the CPU as a whole CPU, replacing the x86 in our data center, right? So currently we are buying very expensive x86 processor as a whole CPU, but we are planning to replace all the x86 CPU in our system, right, without the ASCOM. We also plan to use this CPU processor as a part of the acceleration, right? So some of the computation not doing well by the accelerator, we are actually using our RISC-V CPU to offloading that computation. So this is actually how we actually plan to use this as well. Whole CPU function and also some of the acceleration function with the vector units. The chiplet system, like in the future, like you can see this is one example of how we compose a chiplet system. We have AI chiplet, we have CPU chiplet on the top, we have the memory chiplet on the side, right? GDDR interface, and the bottom we have I/O scale in the chiplet system. So in the future, this heterogeneous compute is actually very important, right? So symbolic AI coupled with a sub-symbolic AI in the future is actually important AI modeling trend. Currently, the sub-symbolic computation is not predictable, it's not secure. For example, you're sending some information that it might be give you a probabilistic, very bad result, right? So it's not safe at all. So for the future generation, AI safety is actually the primary choice, then symbolic AI is the way to go, right? So this coupling between sub-symbolic and symbolic AI is the trend, and our heterogeneous platform is there to solving that problem. So summary, this is kind of funny, right? Wow, AI is such a big market, it's so complex. But you look on AI model is just 600 lines of code, right? You can download our code on GitHub, Llama. It's only 600 lines. But it's a tremendous amount of data you have to process, right? And the complexity of managing this tremendous data and cooperating together, coordinate together is very, very complex, right? So you need DPU, you need GPU, you need CPU. So this is just kind of break it down, right? So how the RISC-V can run in our AI software stack. You can see that it's a hierarchical partition and going from a couple hundred processors growing to a couple thousand processors, right? 64,000 processors. So that complexity layer by layer of the software running in there coordinate perfectly to achieve the performance really, really well based on all the data movement, very, very complex. That's why everybody is struggling about this problem. Okay, my time is up. So why the RISC-V is actually important, right? So I want to emphasize its scalability, extensibility, efficiency, and also its stability, right? That's why the RISC-V is actually the choice for the AI development in the future, and Tenstorrent is using that for developing our AI platform. Thank you.
Thank you so much, Mr. Wei-Han Lien. You may be seated. And I would like to invite our distinguished guest, Mark Hayter, the Chief Strategy Officer and co-founder at Rivos, for his presentation. Please welcome Mr. Hayter.
Thank you, everybody. I'm well aware that I'm keeping you from your coffee break, so I'll try and accelerate proceedings a little here. Great to be back in Taiwan. I spent a dozen years in my Chromebook era forming partnerships with Taiwanese companies, and very successfully, and doing the same thing at Rivos. We're already building up our batch of partners here, and both on the chip side of things and on the system side of things. So it's great to be back here. If anyone wants to chat about becoming a partner with Rivos, I'll be around today at our booth and in the conference. So Rivos is about a 3.5-year-old company. We set up to bring RISC-V to the data center, and our approach was always based on workload-defined hardware, and always looking at RISC-V with acceleration for particular workloads as the initial in before moving to more generic data center compute. We are a worldwide company. We actually have an office here in just next to the Hsinchu high-speed rail station. Kind of nice. You get off the train from Taipei. You can actually from the platform see our office. So always feels welcoming when we come here. I'd like to talk a little about our approach to building AI SoCs. And as I said, workload defined. So the thing that we find most important is to start from the software side of things. We built our software team very early and driving from that side of things. And you have to think a little about why this is important. If you look historically, you see many really clever hardware innovations that were sort of spoiled by the fact that they didn't quite work with the software stack. And saw a lot of this back in the dot-com era when I was cutting my teeth on some of this chip technology. And so very important to look at where the software side of things is as you design. Particularly true when things are changing, as was pointed out earlier, things changing every 3 months. It's an era of lots of exploration. Lots of things are evolving, new models coming out all the time, And what's more interesting is that there's more types of models, right? So everyone was fixated on transformer-based models, and now Mamba came out. And it's not a transformer. And if you've optimized your hardware for transformers, you're going to be very sad. So it's important to have that flexibility. I think the other side of things is there's lots of new build tools, and some of them have been mentioned today, but particularly some of the graph compilers, like Triton coming in and building from graphs to your hardware, but also having the interactive mode that PyTorch in its eager mode brings. So there's a lot to support there. We're particularly interested in the convergence of data with the LLM stacks, the RAG models. And again, this is a good illustration of what a customer would want. If you look at what they do today, they'll say, well, I can download Llama into my VLLM environment. I can pull some embedding models from Hugging Face. I can maybe pull the vector search accelerator from Meta and bundle them all together, stick them under Llama Index, and I have my RAG model ready to go. If you produce new hardware where it's really hard for them to do that, pulling all these individual components from individual repositories, then it's going to be hard to get people to adopt your solution. So very much consideration on the software side. Sort of going in the other direction, yes, it's all change, but lots of people have invested lots of money in existing models, and you'd better be able to pick them up and run them without causing any constraints. And so this has very much led Rivos to adopt the mantra, recompile, not redesign. Sort of exactly what you do if you got the next generation NVIDIA. You take your previous generation code, you recompile it with the latest tools from NVIDIA, and you're off to the races. Yes, you may have to then do optimization for the particular hardware, but our goal is to enable that same smooth flow for anyone adopting Rivos' hardware. The other side of this is the base system software, and this is where we lean very much on the RISC-V community. It's driving the base software and the base instruction set. So it's been very important to see over the last 2-3 years all of the data center extensions going in, and in particular, things for reliability. When you build these enormous clusters of GPUs or other AI accelerators, any failure is going to cause you all sorts of problems, and silent failures are a disaster. So it's very important that we've seen a lot of these RAS features going into the RISC-V world so that you can contain errors very quickly. It's also good to see everyone pitching in on RISE, getting that base software stack established, getting all the things that are needed, numerics libraries, that sort of thing built up, as well as the compilers and kernels and things that we all think about. And the nice thing about the RISC-V community is everyone in it is contributing back into the open source pool. Not just Rivos that I highlight here, but that's good across all of the RISC-V partners. And it's been noticed. So Omdia in their market analysis for servers expressed the view that it was much faster seeing the progress towards data center software for RISC-V than it had been with the ARM architecture. And so the work we're all doing together is definitely noticed by people and is really accelerating our RISC-V ecosystem. So I haven't got to the chip yet. I'm going to consider the system next, because that's MatMul is very important, your matrix multiplier performance. Everyone gears in on that. But that's not the only thing. Models are getting huge. Databases for your RAG applications are getting huge. So you have to understand the memory capacity. Where's that coming from? You have to understand what bandwidths are needed for different parts of the algorithm. You almost never, and I think Wei-Han highlighted this just now, that you're almost never considering a single chip in isolation. You're building them up into nodes, you're building the nodes into racks, you're building the racks into data centers. And so the communication side of things, the communication bandwidth that you get, becomes very important too. I talked before about reliability and why that's important in the architecture. It's important at the system level as well. If you get an error on one node, you really want to take that node out of commission as fast as possible before the error data can spread. Then you can swap in a hot standby and continue your computation. And if you look at some of the numbers that Meta has published recently, they see many failures during the process of a single training run. And it's important that we deal with those. The other thing is, you have to consider that at some point the CFO is going to wake up and start asking about how much all this AI stuff is costing and what return they're getting. So thinking about the power consumption, thinking about the cooling that's needed, also becoming very important. So software side, system side. Finally, I'll get to the chip. The good news here is it can be RISC-V all the way down. We've had speakers talk about this already, but looking at what we need in our RISC-V SoC, obviously what we're building as our crown jewel is our high-performance RISC-V CPU core, competing with the Xeons and the Epics. So it's got to be out of order, it's got to be lots of instructions in flight, it's got to be wide, it's got to be all those wonderful things. That's a very important component, obviously, of our system. But there's more. We found a need for 64-bit controller cores. So these are scattered around the system, they do important scheduling tasks, important system management tasks, and as Dr. Su announced earlier, we're very pleased to have licensed that core from Andes and are very, very satisfied with what we're seeing there. It's important that it be a 64-bit core because it needs to work within the system address space. So very important there to drive it. It's very useful to have RISC-V in all of these because it makes it very smooth from a compilation viewpoint, very smooth from a debug viewpoint. Next stage you find you need is little microcontrollers, scattered around doing I/O tasks, doing power management tasks. And here we can tap into the open ecosystem that RISC-V provides. And we use the Ibex core from Low Risk. I think this is a great example of how the RISC-V ecosystem works really well. This core actually started off as an academic core from ETH Zurich. And they donated it to the Low Risk, who commercialized it, put a verification environment, put documentation, all the things you'd expect around the core. And so that's a very strong open source core that can be picked up and used. And I'm not sure that the students working on it back at ETH ever imagined that it would be in the latest process node running at 1 gigahertz and more. But it's a really nice showing of how things can flow very rapidly from academia into commercial world by using RISC-V. And the final thing that we're adopting, and again, RISC-V based, again from the low risk side of things, with the Ibex core, only the security hardened version, is our root of trust using OpenTitan. And so RISC-V all the way down. So I hope in my brief comments here, I've explained how we're pulling on the software and platform needs. We're building with the efficiency that's going to be needed as systems get big, and we're tapping into all of the aspects of the RISC-V ecosystem, both internally developed, licensed, and open source. And thank you for listening.
Thank you so much, Mr. Mark Hayter. You may go ahead and proceed to your seat. Now, everyone, I believe everyone has amazing opportunity to listen to our speakers. Now we will have a little break. We have a short break. You may also check out the exhibition hall across our venue, and we will back again at 11:30. Okay, 11:30. Thank you very much. Okay, thank you so much for your cooperation. We would like to have our panel discussion. Now, we're not alone because we will have our moderator. Please welcome Dr. Ryan Chen from MediaTek. We would like also to invite our panelists, Mr. Lu Dai from RISC-V International, Mr. Wei-Han Lien from Tenstorrent, Dr. Charlie Su from Andes Technology, and Mr. Mark Hayter from Rivos. Please welcome, gentlemen. All right, Ryan, you ready? All right,
Yes.
the stage is yours.
Okay. Hello, everyone. Thank you for joining us. I'm pleased to welcome you to the panel discussion on RISC-V trend in AI. As presented in this morning, we see there's a strong market growth of RISC-V, and that's a very, very exciting moment. On the other hand, we know that AI technology itself is evolving so fast. So I think it's crucial for us to get prepared. So it's important for us to discuss and prepare for the opportunities and the challenge ahead of us. Yeah, and today we have a great lineup of experts from the semiconductor industry. They all have a deep experience in computing and AI. So, so let's please join me to welcome our panelists here. Okay, so I'm looking forward to a lively and insightful discussion. As we already have lots of presentation here and more at a high level, so I expect that our panel discussion will be more lively and have more discussion in detail. Okay, so and I encourage you to ask questions in the Q&A section at the end of the discussion. Okay, so let's get started. So first, I'd like to talk about the RISC-V trend. And as presented according to the SHD market report, we saw that RISC-V is SoC marketing is achieving a very good business result in last year. With low do that tell us that the number itself is not that important. But I want to say that the 6 billion, there's more than 6 billion in revenue in 2023. And the analysis shows that there will be a compound annual growth rate of more than 40% till 2030. So, I think we are excited to learn from you what's the key factors that are driving the significant growth of the RISC-V, and how this factor or how the demands from this market will steer the future of the RISC-V, the technology itself, and as well as the ecosystem. So, Lu Dai, would you begin first?
Okay, I'll start with that. You know, I was just thinking about the questions, what drives the RISC-V growth. I think there's two ways to look at it. One is, you look at where RISC-V is used today, right? We already seen a lot of growth. We saw RISC-V is being discussed in AI, which is the key topic for this conference. We saw RISC-V discussed in automotive. We saw RISC-V discussed in a lot of new areas. And if you go to our summit in China, you see RISC-V is discussed everywhere. The one way to look at it is RISC-V, it allows the tremendous access to a CPU technology previously maybe only available to a few. It is, I'm trying to, maybe steal Wei-Han's words when he was talking about AI is a new industrial revolution. RISC-V itself is also a new industrial revolution in our industry. The way to look at both is AI is leveling the playing field to make us who may not be, in our college, may feel not as smart as somebody else. With AI, we are becoming just as smart or smarter. RISC-V is also a leveling of playing field that you previously don't have access to a open CPU ISA that now you do have access. And not only you have access, it gives you even more flexible access, and that drives the growth for RISC-V.
Okay. Then how about Charlie? I see that Andy's has a strong business growth as well, and you have many customers from the SoC industry. So could you share with us?
Yes. So I want to talk about things beyond AI and machine learning, even though it's kind of one of our biggest market. But for the RISC-V, there's a lot of opportunity there. So it started with so deeply embedded processor, real-time processor in the application part, wireless, mobile, storage. For example, for Andy's, we have customers using our processor from the small SD card all the way to enterprise SSD to data center SSD. So all have kind of belong to the same category, but they have different requirements to the processor. So certainly in the deeply embedded domain, RISC-V very mature already. We have all the needed tool our customer needs. They can just finish their development and then send it to their customer, and then their customer don't even need to know what kind of processing inside, but they just enjoy the benefit RISC-V bringing a low power, higher performance because the customization, for example, extensibility. In our customer, in the storage part, they're actually using a lot of RISC-V extensibility to directly control their hardware. So this kind of extensibility enables innovation. So one of the reasons is certainly because ARM is kind of stopping there. So in one part, RISC-V is today, in where we are, is because of RISC-V advantage. But the other part is thanks to ARM. They are stopping there. And it seems that for Cortex-M and Cortex-R series, they no longer have future roadmap there.
Mm-hmm. So. Okay, I see. So, Wei-Han, do you have something to add?
Yeah, I actually have a lot of insight about this. So last year, I traveled 15 countries. I talked to government officials, big enterprise, right? So what this semiconductor build out is actually coming from this pandemic, right? 2020. Everybody suddenly realized this global supply chain we actually entrust, last like 20 years actually completely broken where there's a supply chain shortage. And semiconductor has a very high economic leverage. If you have a car, say $30,000, you miss $10 chips, you cannot build it, right? So it's critically important for a country or in a big enterprise to ensure that they have a stable supply chain, right, for their semiconductor product, because the leverage is big. So for the nation, it's become a national security and economic security problem. So then that's why they start build up this semiconductor fab to ensure they have the production. And once you build a fab, then the natural question is that how are you going to fill the fab, right? So there are two things they're immediately looking at. One is the AI, one is the CPU. And CPU, right, from my understanding, CPU is basically the water and the electricity, right? Because current economy, if you don't have the processor, everything gonna broke, right? This is how important that is. And then you look on the CPU, where can you build, right? If you want to have a design capability. ARM is proprietary. X86 is basically closed by 2 companies. The only way you can build with a sustained technology investment is RISC-V, right? I have no doubt in my mind in the future, right, the RISC-V will be successful just because of this reason. For a country to invest long term, for the next 10, 20 years to building a sustainable technology, it has to be open. I cannot go in back to ARM to renegotiate a license agreement. And ARM license, because its current contracts being signed, cannot be open in the future, right? Because it's a violated contract already signed with those licensee. RISC-V is the only solution. And that's why I certainly believe all the big company want to secure their supply design for the processor, and all the country want to do that. We're using RISC-V. It's just a matter of the time. So whatever you actually know, right, whatever you actually learn, you have question mark about the software ecosystem, the country will spend $100 billion to build that up for securing their national supply chain. So the growth is definitely there, right? So it's just a matter of the time. So I believe this growth is sustainable, explosive, even the ecosystem is actually mature. Yeah, that's my view. Yeah.
Okay, thank you.
Yeah, and I think building on what I was saying earlier about the pipeline from academia, getting ideas out there is so much more possible with the RISC-V ecosystem. ARM openly admits that they have a university problem because they don't have a way to license to universities. So x86, obviously there's no license to universities. But RISC-V, universities can do their research on the same architecture that is then going to drive to commercialization. And another example of this, if you look at the capabilities work done at Cambridge, they did it for many years on a MIPS technology base, and everyone was, yeah, that's nice, that's academic, no one's building MIPS anymore. And they tried to do a project with ARM with some success, but it was very much a closed project. But in RISC-V, they could bring their Cherry capabilities, they could set up a SIG. At the European Summit, we saw 2 or 3 other folks had built Cherry capabilities into RISC-V cores, into the Open CBA 6 core. We saw Microsoft had taken Cherry capabilities, built it into their Cherry IoT core, and that pipeline of novel ideas pushing out into the world can happen with RISC-V in a way that's just not possible in the other architectures. And that's going to propel us as well, because we can get the cutting edge from universities right out into the commercial world.
Okay, thank you. So interesting is, in the past, CPU is like water to us. And we are going to have an AI. So AI will be the food for us.
So AI is actually driving a new application, but CPU, there's a lot of traditional computation, storage management, communication, right? You have to have the CPU. I think the transition will have to happen. Like maybe in the future data center will be 60%, but a lot of traditional computation will have to depend on the CPU. Right? So that's where I see like there's a replacement socket for the CPU in the future for the RISC-V, yeah.
Mm-hmm. Then following that, do you think RISC-V in the past, most people, their image on RISC-V is about CPU, the processor. So in the future, RISC-V will, AI will become an important part of RISC-V. Am I correct?
I think that the CPU is well standardized, right? So it has a very clear semantic functional interface going to the compiler. But AI, you don't have that, yes. Right? So the ISA semantic is such a clear defined, such a well-studied research, like 60, 70 years. So it's well standardized. So I don't expect AI will be solidified in that kind of stage and then being generalized in the next 10, 20 years, because we're not even figuring out how human brain is working, right? So I certainly believe RISC-V should do its own best, right? Do the general purpose compute, come with the best ISA, and whatever feature you have to support, hypervisor, data center, whatever. But don't go into the RISC-V, don't go to the AI space, try to create and standardize there, because we actually don't know what's the standard there, right? So
Yeah.
I will be very hesitant to say, oh, that's creating an AI, ISA. I think that will be abandoned absolutely very quickly, just because nobody know what is actually real AI applications. We are trying to figure it out as well.
Yeah.
So.
Okay. Yeah.
Yeah, and I think to build on that, where RISC-V comes out is in standardizing that other stuff. So it's not just the ISA, it's what's called the non-ISA specs, how interrupts work, how memory management works, IOMMUs, all these crucial things, that can be standardized very easily. I agree completely with Wei-Han. The AI stuff, it's all changing every day. If we tried to standardize on something, by the time we've got through all the debates of standardizing it, well, that's how we built models last year, not how we built models this year. So I think we have to be very careful on that. Now, there are components that we might want to build, like the matrix unit that obviously is used in lots of places, but I think we have to be very careful because Microsoft proposed some models that don't have matrix multiply in them. So, well, what if they take over? If we've just spent all our time building these fancy matrix units, we're going to be sad.
Yeah.
I think RISC-V, as we started, is for all computing devices. So it's AI certainly currently is one of the major application. We should kind of from the foundation to see how to support that. From Andy's part, for example, custom extension, that's very important. But exactly what kind of instruction you're going to add, that depends on customer. But we want to lay out the tool for customer to adding all kind of instruction. And then same mechanism can be used for storage, for networking, and so on. Right? So as the technology at the processor level, I think would be more generic. So we look at multiple applications and map to the bottom to see what kind of support we need. So only that we can really kind of achieve our vision of for all computing devices.
Yeah, I mean, another way to look at it is like when we look at RISC-V for AI, this is like a hot topic, right? I mean, it's also the theme for this conference. But when you look at AI for RISC-V, if I use an analogy like, when during the World War II, when you go to Europe and you did this D-Day in Normandy, and that's our AI, right? We're trying to establish our, beachfront, get our first major success there. But we have the whole Europe in mind, and we have RISC-V. We want that to fit into everything, everywhere, right? Just like the previous ISA, they actually didn't define the ISA for a particular market. It was a general purpose, right? And then when it go to a special market, they just add additional co-processors. So look at that way is we can establish a RISC-V ecosystem that can potentially cover everything.
Okay, so then I think we can have more intensive discussion on AI because actually when I'm thinking about organizing this panel discussion, I think this is pretty challenging because RISC-V already cover a wide range, then AI almost cover everything. So the combination of coming together is a broad topic. So I personally think it's because we still need to have some sort of standard, right? To have a RISC-V compatible with each other. Though it's open source, but we still need to have some baseline ISA, have some customer ISA extension. However, on the other hand, AI, just what Wei-Han said, that AI itself is evolving so fast. So how can we, how can we combine this together to keep the ecosystem, compatible or well management, while get the RISC-V catch up with the fast pace of the AI technology itself. And so Wei-Han, I think you already present a lot on what Tenstorrent are doing now. Would you share your experience, how you deal with this, how you leverage the RISC-V part? On the other hand, you still can provide a product to catch up with the fast-paced AI technology. advanced.
So the current processor ISA is a well understanding semantic and also, in terms of its capability. The computation industry is building 67 years behind us, right? So it's pervasive enough going to networking, general purpose processing, embedded application. AI problem is not only solving on the accelerator, you have to solve on the data movement, memory technology, right? So the data movement requires great network technology. Then you have the faster speed to process the network. So you need an embedded CPU for that, right? So when you think about AI, you don't have to mix the AI acceleration or whatever into the RISC-V. RISC-V just have to do well on the traditional computation technology to serving the AI processing, right? So my take on this is that keep the thing you're doing best, right? Doing best. Don't entrench to the area that you know is not standardized, you cannot do best. Because everybody knows CPU is super inefficient doing something. Today, you look on the MPEG encoder decoder, no one trying to put in the RISC-V processor. Why is that? The accelerator is doing so well. Why do they standardize everybody how to do MPEG encoder? So why are we trying to do that? So my take on this is that go wherever you do best on the general purpose compute, traditional computation technology. Come with the best ISA to support that. There's still a long way to go for ISA. Don't go entrench into this AI acceleration engine because it's sexy, right? Everybody talk about it, oh, RISC-V will be part of AI because it's attractive, but it's not. I think it's not being at the stage that you should do this kind of work.
Okay, so then Mark, do you have anything to add? Do you expect what's the priority task that RISC-V or RISC-V community should invest in for AI? Or you have anything to add?
You can tell we come from the same background through the last 20, 30 years, can't you? But I absolutely agree. The pushing stuff into the RISC-V at this point is not ready. And I think the MPEG or picture codecs in general, if you roll back to the 90s, JPEG was just forming, MPEG was just forming, everything was churn. And at that point, trying to do specialized hardware was not the right thing. Now, absolutely, everything's more fixed in those codec spaces. And in that case, and I think where we will get to with AI is it's definitely going to be a collaboration between CPU compute and accelerator compute. That's where it's going to go. So from the RISC-V point of view, what you need is to be able to enable that smooth coupling from CPU compute to accelerator compute. Now, everyone builds their accelerator different, so that's precisely where the RISC-V custom instructions come in. If you've got an accelerator and you want to hook it to your RISC-V core, you can use custom instructions to make that super efficient. That doesn't want to be in the standard because everyone's accelerator is different and what you put there is going to be different. But as we get to the stage where computation bounces back and forth between CPU compute and accelerator compute, using those custom, and that's where RISC-V has actually already done the right thing for AI and enable that custom instruction addition. And not try to say, well, let's assume the models are going to be the same as they are today because we know they're not. So I think very much agreement here.
Okay.
Yeah, I want to follow up on what Mark said, the computation bounds between accelerator and the processor. So it had to be the case. So, I mean, because application is not just all the same, right? So it's different codes and also different form factors. So like the presentation I have for different SoC, usually for the low price application, you will use just one general purpose processor which is powerful enough to do everything. But when you want to, let's take for AI, for example, want to specialize it and you want to have very high performance on your AI presentation in your application, you may want to have a dedicated accelerator to do that. But speaking about the RISC-V's extensibility, so even though you have a special hardware accelerator, but you can somehow fold that into part of the RISC-V ecosystem to instructionalize that acceleration so that your software can kind of visible to that and make it easier to do control, branding to the software. So so I think it's not necessary that RISC-V cannot do everything. I mean, just kind of how we incorporate that. You can as a very separate coprocessor, or you can have very tightly coupled coprocessor. But still, you can issue one instruction and doing a lot of work there. Just that if you have the right programming model, so that is possible.
So what's a traditional computation model proposed by the processor is actually the determinism, right? So AI sub-symbolic computation is probabilistic. It's not secure, it's not deterministic, right? So it's a very, very important to understand the differentials here. A lot of things cannot be processed by AI. I don't believe AI will eventually replace general purpose compute because the determinism you need for security, right? Like for this kind of thing, AI is doing very well on this symbolic neural inference kind of thing, image processing, probabilistic prediction, but it's not good at the deterministic thing. So there are a lot of things you still need to perform deterministic way, right? So you need a process to do that. So they're the process to do what is best. But however, I do want to mention there's a software transition path, right? Software development for AI sometimes is very difficult to write into the AI accelerator. You take time. You write in a C code. You compile with certain metric multiplication. You can build a reasonable performance AI transformation before you spend tons of resource, right, throwing to the accelerator. So there's a transition story you can use the general purpose compute as a software transition story to the AI accelerator. That's the usage is there. But in the future, I still think you need to focus on building the right, instruction ISA for RISC-V, but not to mingle that together. But that transitional usage is there, right? So, Jim told me that, right? In his 30, 40 years in compute, he never see a CPU is not being utilized in the SoC. You always can find a usage. I think for the future AI is the same thing. Doesn't matter you throwing how many accelerators, some people cannot just then program it. So you need the CPU writing the C program, PyTorch compile and working in the day one. Then they can transition to the accelerator. So that path is actually there. So the RISC-V probably need to accommodate that usage model, but eventually you have to move to accelerator. Yeah.
I think I just want to do a little bit clarification when people talking about RISC-V for AI or AI for RISC-V. We talk about AI, we could talk about it from an accelerator perspective. We could also talk about AI as the overall end goal for my SoC, right? So RISC-V, you can have an AI SoC with a RISC-V CPU in there. You can have that with an ARM CPU or x86 CPU. But what's the best fit for our AI purpose? And because of AI is fast growing, because we still are experimenting a lot of new algorithms, RISC-V's openness and its support for custom extension fits very well there. But sometimes when we talk about it, we are not talking into that level of details. We just say AI for RISC-V, right? You can probably understand AI is just a hot topic right now. If you're looking for any kind of venture capitalist, if you tell them that I'm building an accelerator, you're not going to get money. If you say, I'm building something for AI, yes, then we will talk.
So I think, Wei-Han, you just mentioned that the CPU take around 50 years to get the software now is highly compatible, for example, for the ARM or x86. So do you expect it is not the right time for RISC-V to deal with AI in that way, because AI itself is evolving so fast? But do you think in the long run, as the AI algorithm become more established, then RISC-V will aggregate the common part and put it into the part of the ISA standard, maybe in the option or maybe in the baseline standard. Do you expect that will happen? Definitely, it not within the 5 years, maybe take 10 or even longer.
So if it's a well standardized, it actually using accelerator is the best. You know, CPU has a lot of like microarchitecture, like branch predictor, you know, prefetcher, you know, cache hierarchy, low slow pipeline, reservation, staging, all consume tremendous amount of design complexity and power, right? So putting an ISA well-defined, well-accelerated to a CPU is basically a very inefficient way to execute those instructions, right? So I would say that even in the 20 years from now, right, it's very, very likely you have a dedicated accelerator for that. While your CPU doing the traditional computing like operating system management, prevision mode, which is a well understanding academia how to do that kind of thing. So that kind of management task, right, running a traditional C program, like we actually using quite pervasively on the CPU, right? On the just I show you different hierarchy, yes. Right? So there's a PyTorch program you have to run, dispatch algorithm you have to do. You only need CPU and it's being done by traditional CPU, and then everything had to be locking down together, optimized together to get the best performance. So RISC-V can serve in that market already very, very well, because we are actually trying to optimize every segment layer of the software on the particular PPA requirement for the processor. Without the open standard CPU, we cannot do that. We have to go in and say, I have to build this PPA, can I build it? That's a sign a license agreement. But this open standard, you can do basically whatever you want to do, right? It's a freedom, right? Yeah. So there's so many things you can serve in AMI with the traditional RISC-V. I don't quite believe the acceleration is actually should be hitting home here, right? So that's the accelerator do whatever they do well. Traditional operating system, privilege mode, security architecture, determinism and determinism is best doing by CPU. It cannot be doing by AI, right? So there's a clear segment about what the application is.
So how about Mark?
Yeah. I mean, I think let's just to step aside from AI, because I think this might be easier to understand because you know, there's a lot of mystery to AI at this stage. But if you look at the data processing, right? Traditional SQL, yeah, boring stuff. Sorry, everyone will fall asleep. But if you look at what the pipelines data scientists write, yes, maybe there's a hash join that they're doing, and that's inherently parallel, and you pass that to an accelerator. But then you've got some spaghetti Python to do some data filtering. That's not going to be on an accelerator. That's a CPU function. Let's let the accelerators do what the accelerators do best. Let's let the CPUs do what the CPUs do best. I really think that's going to be the case down the road. I think there's many things that will break up into this part of the problem, CPU. That's where RISC-V plays. That's where RISC-V can be really optimized. That's where we focus on adding instructions. Something inherently very parallel, something with a very specialized properties, that's where an accelerator comes in. And get them working together, yes, but try and commingle them, messy.
I see.
I think based on what you have heard from Mark and Wei-Han, based on what we know right now, we don't see that the accelerator portion is going to be integrated into our base size, right? But one thing is, we never say never. I mean, just people know, like back many years ago, the Intel x86 had a mass coprocessor, and we don't talk about mass coprocessor anymore, right? But what RISC-V has is, if you ever need to do that in future, your custom extension could be elevated to become a standard. Right now, you have no need. And if we do need it, and it could be going through what we call market-driven standardization, may the best winner win, right?
So I think RISC-V as a consortium, as a community, an open standard. I think the speed that I don't know where is, when started to kind of start eating the x86 Intel's lunch, but I think that speed with RISC-V probably 2x, 3x faster because of the community. But on the other hand, today in data center, AI accelerator, not just accelerator, so hopefully I can get the funding. So AI accelerator, basically you plug into the x86 server, right? So one server, you can plug in many AI accelerator box, and the whole value chain together actually accelerator even higher than the server itself. So what I want to say is that even though Intel might be there still for a while, but focusing on AI accelerator still can allow the value for RISC-V community as a whole.
Okay. Okay.
Can I just make one more point on this topic? It doesn't mean there isn't some smaller AI problems that were done on the CPU, right? This is one of the reasons why the matrix extensions are being explored. Matrix multipliers, it's a very important building block of AI. It's a very important building block for HPC applications too. So having something like that standardized so that you can do small AI just on the processor, absolutely. But trying to say, let's do an extension for transformers, let's do an extension for whatever comes out of Stanford next month, it's not going to help us. But small amounts of stuff, absolutely.
Yes. Okay. So then another question is, do you foresee any challenges to make use of RISC-V to develop the solution or product for AI? Wei-Han, do you have any comment?
I absolutely feel there's no problem, no anything. I think this is a great standard. Like it actually invented at the right place at the right time. 就中国话讲就是无心插柳反成荫啊。这个就是一个 this technology developed in 2010, and you see my chart AI model acceleration at 2012. It just collide together and work perfectly. Right? It's such a wonderful thing because AI requires so much customization, and then AI had to be everywhere. This is actually give you the freedom while under the one single standardization. So your software stack, if you understand my scalability, right, it can be consistent. The same software ecosystem all the way from the client device all the way to the HPC world, right? Nobody can do that in this time, right? So it's a wonderful thing actually happen at the right place at the right time. I don't see there is any problem, but just when we be careful about is about the introducing too much complexity to this ISA, make it fragmented. I working with the army in Apple, right? Every ISA is being reviewed with a careful study, hardware study, performance study, compiler study, being able to justify the existence of the instruction in that ISA. I respect that kind of due diligence to do, and I think the RISC-V should doing that as well. When you propose something, be extremely careful about what's the implication on the implementation and usage. Don't put too much baggage on this ISA, right, in the future. Because if you actually do that, you will abandon it, and then ISA will become ugly, become fragmented. It's a bad thing to do. So I just wish that's the case. Yeah.
Okay. Okay. Thank you, Wei-Han. Yeah, I think I agree with Wei-Han. LLM or generative AI are so successful because it's open, right? And coupled with the processor part or the computing part, the other x86 or ARM, they are proprietary, so they cannot catch up with the openness or fast evolving AI. And on RISC-V is open ISA standard. I think that's why you mentioned that the RISC-V is the best fit for the AI. They can, I think they can evolve very fast together to deliver the most competitive solution to meet the customer requirement Yeah. So I think that's a very interesting and insightful discussion here. And any question from the audience?
Probably, yeah. I'm from Deep Computing, and I mass produce RISC-V devices. Now we entered into the point that the software ecosystem is very fragmented. And the reason now, we encounter a lot of problems. For RISC-V to scale, you need a very strong software ecosystem. Just now we say accelerators, Python. No one going to push any change to support RISC-V accelerators. So everybody going to do their own customization of their so-called ecosystem, compiler, whatever. But look at Python, PyTorch, they roll out every 6 months a new versions. So, and at the end, the hardware guys and we're lagging behind to upgrading their software ecosystem. Like even Linux kernel support, and you know, for example, right, we have a very good 7nm chips, and then with a very good PCIe, but cannot run on the latest kernel. There's no operating system support it, and you can't run any of the AMD AI car, Tenstorrent car, and NVIDIA cars on it. So it's that end. So I would say now, by the time now we have 7nm, 12nm, I think all the hardware guys should put more resources in the software and don't fragment it anymore. Otherwise, it's going nowhere, right? And everybody have a legacy, a bunch of legacy ecosystem, and not going to scale. And the other thing I want to say is the Android support. Without Android support, I think the device is really hard for RISC-V. Linux is not going to do good on the device side. So that's my point. So
that's why Tenstorrent is pushing for open standard, right? Open AI software ecosystem, right? Try to put everybody together and join develop a consistent solution, right? But the Android part, my take on this is that even Google not doing it, China eventually will do it, right? So if Google doesn't do it, China, they have the risk actually, the Chinese would take a version and branching out building the Android. I see actually that starting to happen. I see people actually show me an Android phone based on RISC-V processor. The government actually has a fundamental incentive to moving everything to RISC-V due to the geopolitical tension, right? So Google will have to do the Android. So just patiently waiting a couple, 1 or 2 years, it will happen. Right, that's my observation. Because if they don't do that, they are at risk of the fragmented, their Android system, they're losing the ad revenue to Chinese maker instead of Google taking itself, right? So I believe that will happen. Just patiently wait, that's gonna happen. Yeah. Client device.
I want to comment on this customization. I think customization is for innovation. It doesn't necessarily going to cause issue with software. So if you understand, let's take PyTorch for example. If you understand that infrastructure, whatever you added, the custom instruction and the custom feature should be wrapped inside a particular operator, for example, right? So if you keep enhancing the PyTorch, I don't think you're going to throw away the operator you provide in the past. Same thing for Erie compiler, there's a microkernel. So you wrap up your custom extension in that microkernel. So even Erie continue to evolve, that your microkernel invoke your specialized instruction should still be there and still working. So it's basically up to how you add your custom extension. I think people know how to work on that already.
I think I will just add on to that as hardware people are waiting for the software to be ready. And software people waiting for a hardware platform to be there, right? So we actually both have to do the job. So it is a leap of faith. It is a new market, new ISA. I think we do have the faith from the engineering community. We see a good technology fit, and we see a very good fit for the market. The market window is also opens. But with any windows open, window also close. So we need to catch the, the best moment. I always believe as an engineer, I need to convince my boss to take on these opportunities. But if my boss disagrees, it's my fault.
I think the other answer to that question is profiles and platforms, which is how we standardize a baseline that the operating system guys can support, the library builders can support, the compilers can support. That's why those profiles are so important. And beyond profiles, platforms will be the next step. That's really going to drive. And I have to put in a plug for RISE because that's an important organization to bring everyone together and do what you said, get the hardware guys working together to drive the software. So you talk to the folks at the RISE booth later, or come and hear Barna talk.
Yeah. Okay. Everyone.
Okay. This is Alan Su from MIcrochip and the NCKU. One of the questions currently Taiwan facing is that how to train more system architects. And then, I just realized that you are all great top leading architects. But the thing is, training the system architect will take 10 years. Do you have any suggestion or possibility to cut that in half? Any techniques or the ways that we could do?
So anyone?
Join Tenstorrent. You will learn tremendously fast. We will cram you days and nights of work, so you will learn tremendous. My take on this, I design processor. There's no secret sauce. You just have to build that day by day, year by year, doing many generation tape out. It's a very, very hard technology, right? Without the tape out experience, without the system architecture, it's just not going to happen. So if a company can do it, country have to sustain building that, using this continued pipeline. Like any design team, like I joined Apple with the PSMI, right? We're starting with 150 people. Before I left, Apple growing to 10,000 design team. The first couple generation Apple chip produces awful, right? And then they putting things together generation, but 10 years later, they become a world-class design team. And Apple really spend like billions of dollars invest on that, right? There's no secret sauce. You just have to do it. Tape out the chip, coming by, it doesn't work. And you build a resource, you build a person, training in the way that you have to do. There's no secret sauce. It's like a running marathon. You don't run it, you don't get faster, right? It's very simple. Yeah, there's no way. So country have to spend resource, company have to continue to invest to train those people. That's the only way. Apple has the patience, right? Keep investing for 10, 20 years to make that happen. Do you have that resource? Then do you have that will as well? Right? It's a very, very, there's no secret sauce. There's no short pass you can cut. No way, yeah.
I fully agree with Wei-Han. Not 10 years, 20 years, or even longer. Right. But I think the key thing is that you don't need to build everything yourself, right? So you should look around to see what kind of expertise you have, and you don't build everything yourself, right? That's how why industry has this kind of IP and build up, and you have chip level and chiplet, using chiplet to build a system. So you should look at where your expertise and use that to kind of use your expertise in the right place. But on the other hand, since we are talking about AI, right? Maybe one day we can have AI for computer architects. But I think Wei-Han would then provide information to that as a training data.
Yeah, just for the record, I've been working for more than 30 years, but I'm not a system architect. So.
Okay, I think the discussion are truly great because I see the time's up for there. So I think that's thanks for the insightful sharing from our esteemed panelists. And I think this afternoon, Frankwell will host another panel discussion. So if you have something more to discuss, I think you still have a good chance to bring them into the panel discussion hosted by Frankwell in the afternoon. And thank you all for joining us, and thanks for the panelists. Yeah.
Thank you so much,
you.
Dr. Ryan. We may have a picture together. You can just put the mic into the seats and we will have a picture. Please move to the center. Yes. Okay. Please make sure you are in the center and we will have a picture. Okay, in 3, 2, 1. Okay. Thank you very much. You may proceed to the seat. Now, ladies and gentlemen, we are excited to announce that the IC Taiwan Grand Challenge is now open. Now, if you are the talented global tech startups, let's join the dynamic and competitive environment. This competition is open for startups, university students, teams, individual focusing on IC design innovations and chip-based applications. So please scan the QR code for more information. You see the price is $30,000 US. Anyone can join. So if you know anyone that wants to have this competition and join, please take a picture, share it, and you will have the amazing opportunity to go back here. IC Taiwan Grand Challenge. Now, before we break for lunch, I would like to remind you to use the meal vouchers at the lunch box at the registration counter, and we will proceed at 1:30 p.m. We also encourage you to visit the exhibition booth, and please make sure that you come back on time for a lucky draw later on. So here are our prizes. There are PX Smart, coupons, AirPods, and Galaxy. Thank you very much, and have a nice lunch. Okay, good afternoon, ladies and gentlemen. Welcome back to RISC-V Taipei Day in Hsinchu. Now we would like to prepare and also invite our guest, Ms. Barna Ibrahim, the Vice Chair of RISE Project. Ladies and gentlemen, please welcome Ms. Barna.
Thank you, everyone. Thanks for coming back from lunch. I am excited to talk about RISE project, RISC-V software ecosystem. We heard a lot about where RISC-V is, where RISC-V is going in the next few years, and how it relates to AI, ML developers. These developers are going to need something on top of ISAs, and what are we doing as a community to get RISC-V ready for these developers? So let's take a look at it. We are going to walk you through what RISE is and how RISE was formed, why RISE is important and playing a crucial role in RISC-V ecosystem, who are the key members coming together to solve this problem. And I got a few people asking questions, and how is RISE related to RISC-V International? Let's take a look at that. Where do we see the challenges? What are the opportunities? And how are we leveraging RISC-V as an open standard ecosystem? And most importantly, how can you get involved? At Rivos a few years ago, we often found a lot of the effort that we're doing. For example, we were working on vector crypto extensions, enabling that in LLVM. Our engineers worked for 2 months, and we upstreamed our patches. What we realized is our co-traveler, Sci-Fi, was also working on the exact same problem. And we only realized that a few months later when the patches are upstream. So the projects had to look at both patches, how to merge it, how to prioritize. And this was not an isolated case. Because we were duplicating efforts, because we didn't realize our co-travelers working on similar problems, we came together and asked ourselves, how can we coordinate better? And can we divide and conquer? Because there is a lot of problems to solve when it comes to RISC-V software ecosystem readiness. So RISE was born because of these issues, and it has 3 goals. First, we want to raise the quality of RISC-V's platform implementations and make that as tier 1 platform like other ISAs. And the second, we want to make sure RISC-V has the best languages and runtimes and libraries, compilers are ready as well. And last, we don't want to duplicate efforts. We want to align our efforts, and we want to go travel together in this journey. So how are we achieving this goal? RISE is doing that in 3 different ways. We're coordinating with our partners. We're working closely with open source projects, and we want them to see us as a resource and helping all of these open source projects to get ready for RISC-V software readiness. All right, so these are our members. As you could see, we have industry SoC vendors that are mature vendors like MediaTek, Qualcomm, and we have RISC-V startups like Rivos, Tenstorrent, Ventana. We also have platform owners like Google getting Android ready. And in addition, distros need to get ready too. So Canonical, Red Hat, all of these companies are joining forces in this cause. Some of the effort, the way we're collaborating is we're getting our engineers together, talking to each other and really collaborating. What are the problems we need to solve and how can we collaborate in this effort? And the second way we are collaborating is we're funding specific projects that none of these members are working on and projects that we think is important. So 2 ways, our resources and our investments. And this is how these members are collaborating together. The important questions I got asked in the booth yesterday was how should we look at RISE versus RISC-V International? RISE was formed May of 2023 as a sister organization to RISC-V International. The success of RISC-V ecosystem, we can look at it as 2 pillars. First, a standard hardware architecture, clear open standards. We talked about that a lot this morning. All of the speakers are aware. All of these extensions are getting ratified, the extensions that are getting added to RISC-V architecture. So RISC-V International is doing a great job in that aspect and leading us to get RISC-V to be on par with other competing architectures. Now, on top of the architecture, we need to have the software ready. So the second pillar in this journey is a thriving software open source ecosystem. Every aspect of the software stack, what's sitting from on top of your silicon to all the way to applications, every aspect needs to be ready and commercial ready, not just ready. So that's where RISE comes into picture. In addition to RISC-V International RISE effort, we have a thriving community, universities working on. So all of these aspects, all of these communities coming together. So you can look at RISE as a sister organization to RISC-V International, and we are constantly talking to each other and really collaborating what areas that needs to be invested. All right. The key topic in the conference has been AI and how RISC-V can be leveraged, and why is RISC-V can be an architecture for AI. A lot of the applications, the developers, when they do their development, every aspect of the software stack needs to be ready. So when RISE members came together and we looked at what are the challenges in RISC-V software readiness, there's 3 things we saw. One, we're all working to get RISC-V ready, but we're not collaborating or coordinating as much. Often we're working in isolation. So that is a problem we needed to solve. Second, there wasn't enough RISC-V developers. We needed to share our knowledge and invest in next generation of RISC-V developers. And the third, really, the coordinating effort. So with those challenges, we looked at every aspect and areas on how we can collaborate. So these are the areas RISE is looking at and working to collaborate together. We're both on the compiler side, LLVM, GCC, one of the projects that RISE is funding is spec optimization for both of these compilers. And earlier, actually, in in the panel, one of the gentlemen asked Python question, right? That was a really important question. We actually just talked about this 2 weeks ago. Python packages like NumPy and PyTorch, often they're not written in Python, a lot of it in C or C++. So they need to be compiled before they become Python packages. And we, as RISE members, recognized this challenge. So we're actually rolling out a project next week. We were just talking about this, so it was such a coincidence. We're rolling out Python packaging support, basically getting key Python packages ready for RISC-V 64. So you will see that coming. And another area for those of us spend some time in x86 world, as you see Intel's platform development guide, it's hundreds of pages. How do you develop on x86 is very well written. And we don't have that for RISC-V. So RISE members actually took it upon themselves. We published RISC-V optimization guide, and it's still in its infancy, nowhere close to how mature x86 or what Intel published. But we started that effort. It's on RISE GitHub. I encourage you to take a look at it, and actually you can be part of the effort, make changes, or suggest what needs to be added. So there are these type of efforts of how best we're enabling developers and really getting the software to be commercially ready. I think earlier Charles said we shouldn't lose sight of our customers. At the end of the day, we're all making products to our customers. One of the questions that often comes up is, if you're all open sourcing everything, what is your secret sauce, right? These are the fundamental software stacks that we're all going to do it together, and we're going to stand on top of that, innovate on top of that. Mark Hayter earlier mentioned how we do AI changing so much. Having the compilers ready, having language runtimes to be optimized for RISC-V architecture are going to give us the ability to innovate. And whether you're developing a product for autonomous driving or AI applications, having these software to be ready so you can do your innovation on top of this. So we're really looking at this as we're co-travelers in this journey, having RISC-V software ecosystem to be commercially ready. And one of the questions was, is there a shortcut? No, there isn't a shortcut, but what there is we don't have to do it alone, as Charles mentioned. There is no shortcut, but we don't have to do it alone. That alone itself helps us to create that shortcut. Few areas, how are we contributing? So we have all these challenges. Software, it took ARM 10 plus years to get into data centers and have ARM to be everywhere from client to all the way to the data centers. How do we get RISC-V to be on par with whether that's ARM or x86? One, we're going to collaborate. Second, all of these open source standard collaborations, whether we talked about whether that's Python or optimizing for language runtimes or getting RISC-V ready for every aspect of compilers. So we're going to do this in open source software stacks. And another thing RISE has done is enabling developers. So we have enabled CIs in various open source projects. So if you need a compute power, you can reach out to RISE and enable your RISC-V library or whatever you're working on and get help from the compute perspective. And we're also looking at how do we do grassroots efforts. So we're launching a program called RISE RISC-V Developer Incentive Pilot Program, and really helping specific individuals who are looking at RISC-V, enabling whether that's small libraries or other projects to RISC-V. So there are three key areas. We're collaborating in open source projects. We're creating compute power to developers so that they have the resources they need to build on RISC-V. And the lastly, really enabling individual developers to continue in their efforts. And how can you join in this effort? There are multiple ways. One is simply becoming a member. And that's not the only way. We launched RISE Request for Proposal program last year. We have done 10 projects. We've invested 10 projects in this. Python packaging is going to be one of them. We did Java language runtimes optimization. So there are multiple projects. We're basically funding projects that RISE members recognize as an important but don't have the resources to invest in. So we're reaching out to the community, reaching out to the maintainers and asking their help to enable different RISC-V projects. And lastly, I mentioned earlier, we're trying to look at incentivizing developers and how could we encourage them to have RISC-V as the default platform as they look at their developments. So those are the three different ways that you can get involved. And as we look at it, RISE is not just a collaborative project. We look at it as a movement that we're bringing all of you, all of us together to get that RISC-V in the next 5 to 10 years to become the default architecture, just like x86 or ARM. So we look at it as RISE as a movement, and I urge you, all of you, to join us in this exciting journey to get RISC-V advanced. So I'll stop here, and if there are any questions. All right. Thanks, everyone.
Thank you so much, Ms. Barna, for your presentation. Now we would also like to welcome our next speaker, Mr. Ted Speers, the Technical Fellow of Microchip Technology, for his presentation. Let's welcome Mr. Ted.
All right. Yeah, thank you. I'd like to first thank Andes for inviting me here. I haven't been to Asia since 2019, so it's definitely great to be back. My name is Ted Speers. I'm a technical fellow at Microchip's FPGA business unit. I've also served on the RISC-V board of directors for its first 8 years of existence. My talk today is the golden age of computer architecture with Microchip and RISC-V. Didn't get training on this thing. Pointed the wrong way. All right, so we're going to talk about a lot of things. Hopefully I get through it. RISC-V, explain how RISC-V fits in the ecosystem. A lot of people have kind of talked about it. And then look back at the golden age of computer architecture. So this is actually a lecture given by Dave Patterson, which really meant a lot to me, and I think set a framework for the future that we can all look to as kind of a roadmap maybe for us all. So I'll make some projections using that golden age framework. Talk briefly on RISC-V vector processing. I've made a big bet on RISC-V vectors. We heard a lot about it today. I think it's promising. And then, a little bit about Microchip's leadership in technical innovation. We really are putting a lot of skin in the game here in RISC-V, and I think you'll be impressed by some of the things we've been doing. And then finally, RISC-V is going to be the galactic standard ISA. We're not just talking about the Earth here. So basically, this slide shows how I view the ecosystem. You can have closed or proprietary and open, and then you have the software ecosystem on the top, and then the hardware implementation at the bottom. And the ISA is the contract between the hardware and the software. And we all know the whole PC era was completely proprietary. Windows, Intel, AMD. So Intel controlled the ISA, and they also controlled the SoC. So you could only get the SoCs from Intel and AMD. ARM made an ISA, also a proprietary ISA. But what they did different is said, well, let's sell IP. So now what that enabled is lots of people could make implementations with the ARM ISA. So that was an important innovation that fueled the cell phone age. Over here on the open side, we obviously open source software, that history's been written. It's a huge success. And then RISC-V here is an open instruction set I think that's a huge set. There's been other open instruction sets, but RISC-V is dominant. But now what's different here is many people can make an implementation of the RISC-V ISA. It could be proprietary implementations such as NVIDIA, open source implementations, or other proprietary implementations like Andes and Sci-Fi offers. And then, just like ARM, a lot of people can make RISC-V SoCs. But so the magic here with RISC-V, what's different today versus ARM, the ARM days, is you have a lot of people who could make RISC-V IP implementations. So as the market changes quickly, the whole marketplace can respond and target various workloads and so forth. So this is really important to RISC-V. So now switching over to the Golden Age framework. This is a Turing Lecture Award. So Patterson and Hennessy won the Turing Prize in 2017. Turing Prize is like the Nobel Prize for computer architecture. And their talk was a new golden age for computer architecture. And they talked about 4 things. And I'm going to kind of focus on 2 of them here. They talked about domain-specific hardware, co-design, and also open instruction sets. These are kind of the pillars of the golden age. And then they use this slide here, basically showing Python at the top running at the speed of 1, and then Intel AVX instructions running 60,000 times faster. And they call that a domain-specific hardware. And so as you move down here, the hardware is getting more productive. But as you move up, the software is getting more productive. It's much more quick, much easier for a developer to use Python than to develop in C. And then it's very, very unproductive to write microcode for AVX. So then they talked about, in addition to domain-specific hardware, domain-specific languages at the top. So that's even 1 layer higher. These domain-specific languages help you in one domain, and they can be built on either interpreted or compiled languages. And so TensorFlow was the domain-specific language that was really popular at the time for AI. It's actually written in Python, but as Barna pointed out, Python is actually implemented in C. So in 2019, I said, this is great. So this provides a roadmap. So I did this talk. I said, we got to span this. We got to connect the domain-specific languages with the domain-specific architectures. And I said, what is needed? Open hardware standards, more investment in hardware startups, more hardware engineers, make hardware cool again is a term I used. How are we doing? Well, RISC-V is doing great. And we have our own vector extensions, which are comparable to AVX. More investment in startups. A lot of startups here. I don't think you can have a startup today that's ARM-based. Startups have to be RISC-V based. Make hardware cool again. I think we're getting there for sure. I think in the stock market performance, hardware companies are outperforming software companies now, so hardware is definitely cool. At the top, I said, keep doing what you're doing. There was no problem with innovation at this level. In fact, I think PyTorch has supplanted TensorFlow in this particular aspect. Then I said, more focus on compiler technology. I had no idea what that meant, but this is really what fills the gap, right? Then, sure enough, 2021, the golden age of compilers, Chris Latner made this talk. And he talked about we need to compile to these DSAs. We need to enable all these domain-specific architectures, but we need software to be able to target these heterogeneous compute platforms very easily. So he talked about MLIR, so I think that was referenced today in the Andes talk. So it's multi-level intermediate representation, and this is Chris's hope. This is the answer. This is the golden age of compilers. This enables people to write compilers to target heterogeneous hardware. So recipe of the future, more focus on compiler technology. MLIR stepped in. I think answered that question. Obviously, other ones are there, but I think this is the golden age of compilers was filled by MLIR. So Chris, I don't want to be doing too much of an advertisement for him, but now he has this language called Mojo. Does it complete the puzzle? So Mojo's designed to solve a variety of hardware AI development problems, and it's the first language that's developed on MLIR, so he's eating his dog food. And then it's Python. It's a superset of Python. So, you know, we had a similar chart, so they accelerate from Python, something written in Python. You can add types, vectorize, all these are Mojo capabilities. And you can get a 455,000x acceleration of MATML using Python targeting a specific architecture. So if I look at this future, we got the DSLs at the top, and then we got DSAs, domain-specific architectures at the bottom, and I'm going to separate out RISC-V powered DSAs. I think this is what the world we all want. And basically, Mojo is inherited from Python. So we kind of got this path now. DSLs can be written in Mojo, which then can be compiled to to anyone's DSA. So this is a possible. At the end of the day, software is going to be the answer to how all this innovation gets enabled. And this is one example that one future I see is possible with this golden age. So what about vectors? So DSAs are being built. There's a lot of startups building DSAs. And everywhere you look, there's vector processors. So Cerebras, GraphCore, Xilinx, or AMD, Esperanto, Meta, Tenstorrent are all building these giant arrays of vector processors. And these ones at the bottom here are RISC-V powered DSAs. So this is the story we want to continue to write. We want innovation here, and we want it to be RISC-V based. So just about, briefly on RISC-V vectors, kind of the way I like to look at it is it's a very simple ISA. It's easy to understand. So this basically, add two vectors together in registers 2 and 0 and put the destination vector 4. So register 4. Simple ISA, but optimizable hardware. You can optimize for your application. You can optimize the VLAN, the length of the registers, depending on your power performance. And you can also optimize the ALU for the same thing, for power and performance. But you can get, one binary targeting all these architectures, and because there's a lot of flexibility on the way the register file is interpreted, you can actually control the state, how the software is viewing all this hardware. So it's a really powerful vector ISA. So MIcrochip, switching now, extending the reach of RISC-V. So in the 2016 summit, we introduced a soft IP, RISC-V soft, and so this is a program, an IP that RISC-V core that runs in a FPGA. And then in 2019, we announced a SoC FPGA. So we make a product called PolarFire SoC, which is a quad-core RISC-V application processor and a monitor core attached to our low-power, secure PolarFire FPGA. And then we have an ecosystem we call the RISC-V, or Mi-V is our RISC-V ecosystem. So we're like one of the first companies that made products that the user can actually program. We were not deeply embedded at all. And then in 2022, we announced PolarFire 2, which is going to be RISC-V enabled, but we also announced something called HPSC, which is the high-performance space computer. So a little bit about this. The details started coming out on this at the Space Computing Conference earlier this year, but at the heart of it is 8-core, 64-bit RISC-V vector processor being created for, as a contract under NASA to basically dominate the space market. So a lot of work, there's hardware, but we're doing a whole Mi-V ecosystem being expanded to support a vertical. So we're the first company to show how to take RISC-V and to own a vertical. So, a lot of applications across the top. And, my belief is space is important for space, but it's also all the needs in space, low power, security, high density compute all applies to the edge, so it's going to be applicable in other markets as well. So a lot of work on the software. So we have an existing customer, has a lot of needs, and we're building the silicon and the ecosystem, and RISC-V is at the core for space market. So, really, we want to connect a few things. So NASA basically had these requirements: more compute, more AI, more I/O bandwidth, red hard tolerance, cybersecurity, and they wanted open standards. And NASA was tired of having their own proprietary stuff. So we can solve that problem with RISC-V. And NASA's there with missions to Mars and so forth, but there's a huge commercial space market that's developing as well. So I'm a big believer. I mean, I saw RISC-V early, but I've actually been a big believer that what matters in space is going to matter on the ground, or vice versa. Technology in the 60s, I think space is going to drive the technology going forward. You may not know it, but your company is going to have a straight space strategy sometime. So I did this keynote in 2021, and I said, RISC-V is going to become the galactic standard for ISA. So this is even before HP existed, and we're well on our way to expanding beyond the ground here. And what's going to enable that? This is Starship from SpaceX. It's going to drive launch costs down to nothing. It's going to cost nothing to launch your payloads. And this is a huge thing. Shown there is a 747, which is tiny compared to the Starship. So the roadmap to the next golden age. Open and flexible ISA, moving from ARM to open and flexible is going to be important. The expanded ecosystem is important. You can have lots of suppliers to solve your specific needs when you need to innovate. That's enabled, by the RISC-V standard. And then, but more industries, investments needed to enable software to basically target all this. So I think that's the conclusion of my talk. Thank you.
Thank you so much, Mr. Ted. Now we are going to welcome Mr. Travis Lanier, the Chief Product Officer of Ventana Microsystem, to come on the stage. Please welcome Mr. Travis.
Hi, good afternoon. I'm Travis Lanier. I'm the Chief Product Officer at Ventana. I've been doing CPUs almost 30 years, and I've been involved, I was at ARM for about a dozen of those, and I was at Qualcomm for about another 10. So if anyone wanted to talk about why RISC-V is inevitable, I've got probably a few stories I could tell you over a few beers. But anyway, there's a tremendous amount of traction, and I'm going to talk to you about what Ventana is doing in the AI space, if I can get this to advance. So we've traveled around the world the past year, and we've talked to OEMs, hyperscalers, and various end customers. And what's clear is there's tremendous momentum and traction for RISC-V, with real design wins in the data center space in HPC. So you'll see things start to happen over the next year or two. But the other thing that's become abundantly clear is that there's a massive change towards AI. So everyone's excited about RISC-V, but when you go talk to them, they say, what's your AI story? So let's talk about that. RISC-V is going to be a big component of AI. We've talked about that today. And it's going to be a balance of what you see with traditional scalar compute. I think there was a great discussion on that earlier, where obviously the traditional compute is not going to go away. But you are going to see AI show up as a component of almost everything going forward. So let me tell you a little bit of history about Ventana. Most of the people at Ventana were involved with companies that did the first ARM servers. So question may be, well, why did you pivot from ARM to doing RISC-V? And one of the key things our motivations for moving to RISC-V is this concept of domain-specific acceleration. And we've heard people talk about that throughout today. And when you look at AI, it is, in effect, a form of domain-specific acceleration. So that's why we think that RISC-V is the future. And this is true across a variety of applications. You can look across the breadth here. There's just general AI computation in general, but data center, automotive, the intelligent edge, all of them are going to have some component of AI in it. But the key thing is it's going to be a little bit different. It's going to need a little bit different scale of AI components. It's going to have different models. And each one of these things are going to need to be customized. And that's where RISC-V's strength is. So you can optimize it for the particular application or performance level that you need. Now, this is a big number. We got this from one of the analysts. $22.5 trillion economic impact over the next several years from AI. Now, obviously, it's a big gold rush. Everyone's going, hey, I have to go and do that. There's a whole bunch of startups saying, hey, we're going to have an AI solution. We're doing an AI accelerator. But it turns out, why aren't all these guys printing money right now? There seems to only be not that many companies, at least on the hardware side, getting a lot of traction. And we feel that comes down to a lot of it is software. And some of it is just over-optimizing or focusing on specific things. So you can look at a whole bunch of accelerators from a few years ago, and I think people touched on this earlier. There's a bunch of companies that went out and did these excellent accelerators for ResNet. Right? Hey, this is the greatest thing ever. They had these fantastic benchmarks. And then, oops, a few years later, yeah, ResNet's not exciting. I want to run transformers or LLMs. So, okay, so you over-optimize and you added too many specific things in there. The other thing is people create a chip or they create a platform, and it's for one end of the spectrum. Hey, I have a data center accelerator, or I've got this really tiny thing that I go put in, and that's going to go accelerate a chip that goes into your eyeglasses. So you need to be able to adjust to your market. So you want something common, but you have a lot of these companies in different places all designing something unique, and so you can't scale to the workload with these solutions. These companies are just focused in the one particular area. And then lastly, you have the inability to keep up with AI innovation. And this kind of ties into the first point. You can optimize for what's hot today, but you need to be able to keep up. And if you have a locked-in ISA or you're using someone else's solution, you can't easily modify that to keep up. So in the end, what you need is open hardware and software stacks, so you can have a common base to build off of and not reinvent the wheel every time you try to do an AI solution. We feel that RISC-V is the key towards solving a lot of these problems. Now, there was a panel up here earlier. I would like to have been on it because I had a little bit of a different opinion. I don't think we're as far apart, but I think a lot of things probably do need to be standard in AI. Now, it doesn't mean it necessarily has to be in a profile and included in every RISC-V processor, but if you can standardize on basic operations that show up over and over again, there's a huge benefit. I saw Lu Dai actually talked about floating point. I've actually used that in some of my discussions whenever I talk about AI, is that it used to be optional in x86. If you go back to the 286 and 386 days, you could actually get different floating point solutions from different vendors and then attach it on. Anyway, my main point here is, let's go through these points and I'll talk a little bit more about that one. But if you standardize on the software instruction set, right? We've standardized on vector. We have a pretty good vector extension. You should be able to standardize on some of these other things. Now, will matrix be important going forward or not? I don't know. But matrix math can be used for multiple things. And there's a lot of pretty standard operations in matrix math that you could probably all agree on, and then leverage that into standard software support, which turns out to be one of the top problems that people encounter when they're trying to do their AI solutions. So you have all these companies trying to do an AI accelerator, and then they have to go and rebuild a complete software stack to go try to compete with CUDA. So if you have these things standardized, you can then just focus on what you actually need to differentiate rather than trying to rebuild the whole stack. Then, of course, you can scale your solution once you have the right solution. So I talked a little bit about this before in some other places, but we call this RUCA. And this just means RISC-V Unified Compute Architecture. And the idea here is that you try to put as many of these operations as you can into RISC-V. Now, you're going to want to innovate on top of that and have some customizations, but there's a lot of standard things you can do with vector. There's a lot of standard things you can do with matrix math. And if you can build your software on top of these standard extensions, then you've gone a long way towards standardizing your software stack and having to completely rebuild your AI software solution. RISC-V gives you that ability to also do what you want to do on top of that. Then you also get into some other architecture advantages when you have a unified RISC-V architecture, such as you not necessarily have to use software to push things back and forth between the accelerator and the control CPU. Chiplets is another dimension on top of this. So RISC-V and DSA lend themselves well to this chiplet idea, where rather than having to do this monolithic approach that you see here on the left, these chips are huge. They take years to come to market. It can take hundreds of millions to go develop. And the idea here is if you have this concept of RUCA chiplets, this is smaller RISC-V cores, not necessarily these large ones, but then you can pair this up with this right here would be the idea. It would be high-performance RISC-V cores. And then you have in the middle here, or at the bottom actually, this concept of an I/O chip. And you attach these all together, and you start to have an AI solution. And the idea here is that you can scale these up in the different ways to create the solution that you need at a much lower cost point. So rather than trying to develop the whole thing on the left, you just take the components you need or redesign the particular component you need and then scale it up or down. So just as a reminder, Ventana is focused on high-performance CPUs. On the previous slide, we showed the RUCA cores and we showed the scalar cores. We're focused on the CPU server portion of that. So we're aiming to have the highest performance RISC-V cores that can compete with the latest from x86 and ARM when that comes out. We'll be shipping these platforms to customers next year. And we'll probably be shipping in volume in data centers the year after that. So we'll be sampling next year is when the first one of these x86 or Xeon class servers will be coming to market. And what we have here is a visualization of how you can put together these components to create an AI system. So what Ventana has here is our Veyron RISC-V server. This is the thing that Ventana is focused on along with the I/O die. We have partners working for the I/O hub. And what this allows our customers to do is focus on creating these RUCA cores or RISC-V type solutions, and that ties into the platform. And that allows you to create a system that can scale up in performance. And the idea here is we want to try to leverage as much software as possible. So work has already begun in the RISC-V system. We've already had people talk about this today. And what you see are plenty of projects already being ported over to RISC-V. Many of these are the key ones that you need to be doing AI. And at Ventana, we've taken this a bit further. I typically usually show just our data center software stacks. What we've also already begun to do is actually take these individual components and run complete AI software stacks on RISC-V to prove out this concept of RUCA and running various things such as like TensorFlow or PyTorch on top of that, top to bottom on a RISC-V platform. So just to drive home this platform concept a little bit further, we're not just focused on the CPU. We want to have a complete system that's put together. So I mentioned earlier that we did the first, or that this team actually did the first ARM server. So we had a lot of experience with what it takes to bring these things to market. It's just not enough to say, hey, I've got a CPU and say you're done. So there's been a lot of talk earlier today about profiles and how do you get things standardized, not just from the CPU perspective, what goes on outside of that and how does your system boot up, for example. So we have a high-performance CPU. I showed you the software stack, so we have a lot of these things available today. You can go download our SDK, and it's not just a piece of the software, but we have many of these complete software stacks ready to go for the data center. We also have enterprise-grade system IP. So it's not enough just to have the CPU, but we have the IOMMU, which allows you to virtualize your devices out there. Then you have various types of DSA. We have AI type of acceleration. So I showed you some of the software that we're working on there. And then domain-specific acceleration for various types of other things, such as encryption or database acceleration. We've also focused on chiplet technology. We're also pioneering how do you stitch these things together to create these systems in a low-cost manner. We've also made sure that our IP and our chiplets will be automotive-grade certified, so it allows us to go into these other markets. We've taken a fresh approach to security. So not only do we have the standard things you'd expect to see, like, okay, how do you deal with trust zone, or how do you have a secure computing environment? We've made sure that we're resistant to side channel attacks from the ground up. We have extensive RAS features, such as data poisoning and error protection on our IOMMU. And we have a low latency NOC, which allows the CPUs to communicate with each other in a high bandwidth, low latency fashion. We also have a high performance cache architecture. So again, it's one thing to say I have a high performance system, but when you have these large data sets that you see in AI or in the data center, you need to have a high performance cache to go along with that. And lastly, we're at feature parity with the other architectures now. So that's a big thank you to the rest of the RISC-V ecosystem. The things have moved very quickly to bring RISC-V up to parity with what you see in the x86 in the ARM space for getting into the data center. So with that, I think it's pretty clear from today that AI will be pervasive across all tiers of computing. But my main point is that I think that there's a common architecture and software base that is required to get it across all these different applications. We feel that RUCA is one way to do that. So you can add these extensions to RISC-V, and you have a base that you can build off of. But achieving this requires a platform. And so that's what we feel that Ventana brings to the ecosystem. So we can pair up our server base with various RISC-V RUCA chips. So Ventana will be partnering with people to deliver these types of platforms over the next couple of years. Thank you.
Thank you so much, Mr. Travis. You may proceed to your seat. Thank you very much. Okay, for the mic. All right, so I would like to remind everyone, if you still have your colleagues outside, we want to have a lucky draw, so please remind them. If not, they will miss the chance to have our prizes. So, okay, now I would like to invite our next presenter. Please welcome Professor Tien-Fu Chen, the Vice Chair and Convener of RISC-V Taiwan Alliance. Please welcome Professor Chen.
Thank you. Yeah, okay. Yeah, it's my honor here to share some research efforts in RISC-V LLM interest group. Actually, it's in our school. So I come from the National Yangming Jiaodong University, and I would like to share some research effort result. Okay, as we can see, right now we are in, actually we can see the AI development is moving from the big data to the big variables, and we can envision in the future will become a big model era. So based on the lots of the statistics data we have and the knowledge experts system, we can have a very good AI assistant to write the business intelligence. But given with the so far, we right now already in a kind of the model with lots of the variables, just like BERT or even those large language model. So based on this model, we do need a lot of data. We need to have to collect sufficient data in order to train our own the model. But eventually, those models will getting mature. So, and then there are lots of thousands of a model will come up ready. It can become a big model era. Okay, so as we see lots of examples already shown, the generative AI would be very helpful to us. So the McKinsey report in the last year say even those the application with the existing AI, there are lots of the contribution to the to the industry. By introducing the generative AI, we can even further improve up to 40%. But if we further combine those existing technology and with generative AI, we can even further improve up to the 70%. So overall, you can see the impact of the generative AI is quite huge. Okay, so but if we look at the details about the category, the generative AI can help. Most come from the STEM professionals, people with the STEM professionals, just like engineer or science and management. So you can see they can improve from about the 16% up to 30%. So the performance, the productivity improvement could be quite huge. And you can see there are other several categories showing the similar result. So as we can see, even in the United States, the Y Combinators, there are so many investment already put into the new startup regarding the engineering, regarding the sales and or customer support. Those are all the new companies come with the generative AI. But the recent report from McKinsey, again, they say if we already have a company with already have a good knowledge chatbot, or you have a good AI personal assistant, and also there are several generative tools ready, you can combine them together, and then you can even have a more powerful tool available for the company in order to produce, to improve the engineer productivity. Just like you can combine those together to get a customer-facing chatbot, or things like you can have an automatic FAQ generation. So those total value could be even further for your company future development. So this case could be quite promising in the future. This is another reason we can see is the open model like Llama or Mistral, things like that, is getting better than ever. So it could be, with the sufficient data, it could be quite, it could approximately approach those closed model. Once those open model is ready, and then with our high performance architecture, we can come out even better application AI. So right now, let me just summarize the possible topics for the IC design with LLM. So it could be IC design for LLM. We particularly design the special IC or a computing platform for executing the LLM. On the other hand, we may use the LLM, large language model, in order to improve our IC design flow. So yeah, there are lots of the topics, interesting topics can be pursued. Okay, so today I would like to just show a few examples. If we just consider the software side and how we can use the LLM improve our software design. Okay, and then later on we will show if we can have a good study or particular software effort in order to put the LLM, the tiny LLM in a very small system. Okay, so let me show the first. So the first thing, if you would like to have a large language model running on our processor, so it should be very small and very energy efficient. So the first goal would be try to minimize the model, or even have the system design with a very small memory requirements. So it's topics of the edge computing, or so-called AI landing. So right now we already try to demonstrate a small model can be running on the Raspberry, running on the Jason Xavier and N3000 is designed by a new chip, and we can show some example on the Mac Studio. So we look at the problem, we divide the problem into 4 aspects. One is if we can see a good example, a good application can be demonstrated given those very small system. So this is application label. Within this label, we have to provide a very specific and precise prompt engineering. We have to provide the prompt template to show if those application can be best fit to this tiny system. So this is the label between the application and the API. Under the API, we have to build some sufficient generated technology, just like a reasoning agent or the most popular RAG, retrieval augmented generation. And behind the API, there are lots of the foundation models available at this moment. But usually we have to look at the smaller model at this moment. And under the foundation, we can see there are lots of the hardware available, just like RISC-V or Raspberry or the industrial PC accelerator. So in order to fit those applications into a small system, so we have to first build some the basic system module available. And we divide the problem into the 3 parts. One is that we have to provide the module in order to process the data at in a very efficient way, such that the inference can be easily deployed. So we have done the knowledge acquisition modules, things like the parser or the multimodality understanding. And then we have to consider how to perform the inference, the LLM reasoning within a smaller system device. So it kind of the fine-tune and the mixture of the small model within a small system. And later we have to see how those data can be come out, how the data can be presented in a reasonable way to the your users. So once those things are done, and then we can have those application landing at the device. So we have done lots of the benchmarking and evaluation based on those hardware. Okay, and this is a small example. We show a small language model running on a 2 Raspberry. Those models include lots of the feature here. Let me show you a demo. Oh, okay. That's too bad. I cannot see the demo video. All right. Yeah, if you are interested, let us show you later on. Okay, so, all right. Okay, so the previous example just show you a small model, how can a small model can be realized. The Llama 1 megabit, not 1 mega parameter can be run on the 2 Raspberry. And it come out lots of the mixture of experts, small experts. And for the second part, I would like to show we can use the large language model how to improve our design productivity. So the point is we have to collect sufficient data in order to fine-tune a company-owned small or self-owned language model in order to perform our the productivity. And then eventually we hope the large language model can be landing at the edge devices. So this is several ways how to fine-tune the data or try to do the agent or the RAG. Okay, so let me show you the first example. This first example, we built a RISC-V experts system. It's basically it's kind of the knowledge assistant. So the source comes from the lots of public data available on the web, including the menu, textbook, material, or even the GitHub code. And also we collect several lots of the Q&A from the Stack Overflow website. And the data amount, the amount of data is not so huge, but it's good enough in order to answer some questions. And in addition, we particularly emphasize, rather than a text Q&A, we also provide a very rich data format. This is quite useful for the engineer because we can show the state diagram, we can show the protocol, or we can show the state of transition. So, there's a video demo here. No? Oh, it's too bad. Can you play it back? No? Too bad. Yeah. Actually, I have 5 demos. So this is the second. Okay. It's okay. Okay, let me go further. So the tour, second. It's just a regular RIG. Because we can see most companies, there are so many products with very large menus. And for the engineer or for his customers, I think it would be difficult for them to read those menus. So here I just show, given just like this example, there are more than 300 pages of the menu. And with a certain RIG or assistant, we have an advanced RIG system, and we can identify and can answer the question precisely, extract the information from the information retrieval. Okay. Okay, and here I would like to show, it's another demo. And here I would like to show if we have so many products there, and if you can perform the kind of the product comparison, show what kind of difference these 2 products can show. So we can specify the lowest field of interest you would like to see, and you just feed the data, the menu, and we can generate a summary report to precise compare side by side the key difference, the certain numbers or parameters difference between those different product spec. And it would be quite helpful to the engineer to see the particular points I have to look at. Okay, so this is the third tour. And also, we show this another demo, okay? Unfortunately, I can play it at this moment. Okay, the fourth tour is a summary. So for example, for the Intel, we have Gen 10, Generation 10, Generation 11, or 12. And I would like to see if the cache, regarding the cache, or regarding the bus bandwidth, or anything, the design parameters, I would like to see the key features between the difference between those generation. So with this tool, we can extract the information from all the documents, and the user can specify which feature you would like to look at, and then we can summarize it in a table. So, and finally, we produce the report as a PDF, and then you can look at the whole details. Okay. The fifth tool is a test case generator. We have the RISC-V assistant and the test case generator. We have a demo in outside booth. For the test case generator, as we know, we already have the Copilot tool ready for the engineer. But if you develop a certain code, you would like to take a test, you have to write a test case. Okay, so with this tool, you just put your code there, and then we try to understand your module, and we see your input and output. We let the LLM understand the input and output, and we generate the data for you. Okay, so the case is here. the user provides his code. And we have the parser, we provide the prompt, and then let the local on the large language model to understand the code. And we let the code generate the test case, the test data. And then we have a system to integrate with the compiling and execution and produce a result for this test case. And then it come up a result. So we build another prompt builder to look at the result and check if the coverage is good enough. Because for each test case, we would like to make sure if the test case can cover certain aspects. So we would hope the coverage could be close to 100 as possible. So this the group is trying to reach the coverage to improve the coverage. So once under the constraint, the time or the resource you specify, finish the coverage execution, and then we can generate a report. We can have some sufficient test case for you, and we also report some error if some test case does not pass, or we have some result regarding the time limit exceed the problem, and overall we release the final result as a test case, a test code for your input. So this is the overall system flow. We have some example outside. Okay. And finally, because there are lots of the interest in a tool can be pursued for in order to improve the productivity. So we build a studio. It's kind of the generic agentic AI flow. So user just plug and play the steps and the agents, and we can build the application, the Gen AI application to improve the engineer. So I finally conclude my talk here. We see right now we are still in the text training stage. So the conversation is just a kind of the text generation, the text sequence. But eventually we will enter the Chen state. Chen is a kind of, each problem can be divided into certain steps. And each step can be solved by the different agent AI flow. And then we will eventually enter so-called closure inference state. So that each stage will determine some decision or make the decision or depend on certain input, and then eventually can be combined with a large language model together and then come out very high level and powerful the system for the whole design phase. Okay, that's the end of my talk. Thank you.
Thank you so much, Professor. Thank you very much. Now I would like to welcome our next speaker. Let's welcome Mr. Ted Chang, Convener of RISC-V Taiwan Alliance and also the spokesperson and special assistant of Andes Technology. Please welcome Mr. Ted.
Hi everyone, thanks for your coming. My name is Ted Chen. Today I would like to introduce the platform SIG for you. Compared with LLM SIG, the platform SIG is quite different because we are service-oriented SIG. Before my presentation, I have to, from the RVTA point of view, I have to thanks to Andes, especially thanks to Frankwell, because it's not easy to get this kind of SoC chips. Because I believe Andes spend a lot of effort to create these SoC chips. So today we have such kind of platform SIG can service our members and our partners. Let me start my presentation. Let's talk about the reason why we want to build. We want to establish our platform SIG. I believe it's because we want to promote the application of RISC-V. And of course, we want to promote the RISC-V technology by system-level demonstration, not only software porting, but also included the whole system, including the board and the test chip. And we order, in order to promote RISC-V technology and the use case in various applications. And we'd like to support our technical partners, and we'd like to align us together. We can share the information to each other, and we can strengthen our ecosystem. And the most important to us is that we plan to deliver the RISC-V value, and we try to help our partners, our members, to create their competitiveness. This is the reason why we want to establish our platform SIG. And right now, this organization is just beginning, so I'm the technical leader. And they have two distributors from Andes Technology. One is Mr. Ye, the other is Mr. Xie. And right now, I'm under recruiting our team members. That if you have interest, you can contact us. The team members have some rights and application. You can access platform technology information. You can participate in some activities like platform promotion plan or even some expertise sharing their technology. And talk about the action plan. Besides today's activity and the recruitment program, next month, middle of next month, we plan to hold another promotion activity in south of Taiwan, Kaohsiung. So if you have interest in or you have a branch office in Kaohsiung, south of Taiwan, please reserve your time to join these activities. And I believe the most important for this platform SIG, as I mentioned, this is a service-oriented SIG. So we plan to bring the benefits and the value to our members. So this platform will bring the real-time CPU performance evolution because you will break through the speed and limitation of FPGA. So you can really to port in your software, and you can see the real result from our systems. And it also can repeat the software development. As you know, because R&D, especially software R&D, they spend a lot of time to design their products. But if they cannot run in on a real platform, they will suffer some risk. So it will save their time and increase their confidence. And of course, they can easily to develop more software applications that are difficult to verify with FPGA. And of course, you can share more application demos from all the partners. Those partners will help you to create your software. And what the platform SIG do for you? Yeah, actually, if you need, we plan to do the demo for promotion and education. And we'll help our partners and our potential partners and our members to evaluate your software IP. And you can do the software performance testing and evaluation. And of course, if you have planned to design a RISC-V based SoC chip, you can base on this platform to verify our CPU core, like X45MP and NX27V CPU core. You can, you don't need to imagine, you just can see the real result from this platform system. And let me introduce this platform technology. As you know, this platform adopts the 0-nanometer process from TSMC. So I believe Frankwell spent a lot of effort and investment on this chip. So this SoC chip equipped with 2 CPU core. The first one is X45MP. This equipped with 4 core. And second one is a vector CPU, NX27V. And the memory were were equipped with 32K I cache and D cache and 2 megabyte L2 cache. 27V equipped with 32K I cache and 512K byte D cache. And the max frequency, the worst case, X45 MP up from the minimal performance were 1.5 gigahertz and up to 2.2 gigahertz. In general, we're up to 2 gigahertz and above. And NX27V, we're up to 1.1 gigahertz at worst case. And this design is more simple. It will be more convenient for software porting. So it only equipped with PCIe peripheral. You can leverage the PCIe interface to extending your peripheral interface. And we support the SPI NOR and NAND flash interface. And the DDR spec is a 64-bit DDR3.4 up to 16 gigabyte. We support some low-speed interface, included QSPI, UART, I2C, and so on. And this is the platform system architecture. So just for your reference, the core name is QL7200. And this is another system diagram for your reference. Actually, we have live demo on next door, so you can visit our booth to see the real demo. This demo will equip it with graphic card, SSD, and USB hub to do some operation and demo. And let me make some times to update the RISC-V status. This page Lu Dai already showed before, so I don't want to mention too much. What I want to highlight is, like mentioned by Lu Dai, the adoption rate is increasing a lot. So before end of last year, the RISC-V members increasing a lot. And we predict this year also, we will foresee the big growth of the membership. And this is RISC-V members grade. So from Premier, Strategic, and the Journal members. And talk about the ecosystem, we believe is quite important because this is one of most key point of RISC-V. So we believe in the past decade, there already have been more and more partners join this ecosystem already. And talk about the application. We not only the endpoint, but also the enterprise and AI and automotive. So you can see they already have a lot of application they adopted RISC-V CPU inside already. Talk about the future of RISC-V. According to the research institution of Omdia, they predict that the growth of RISC-V will concurrent with the rise of AI and especially edge AI. And they predict that in the next 6 years, the total shipment of RISC-V processors will increase by nearly 50% per year. It's quite big numbers. And they predict in automotive, also they will adopt RISC-V, and the shipping volume will almost over 66% annually. And they predict that not only automotive will adopt RISC-V, and also the AI solution will equip it with automotive, especially on ADAS and IVI. And of course, we can see right now, most of our applications, they try to equip it with AI function. So we believe in the near future, the RISC-V CPU will be the major core technology of AI. And in the end, let me introduce the software that we already porting on our platform. This page shows what kind of software we already porting on our platform. Zephyr from Atos, and OpenAMP, and of course the most important one is the Linux distribution. They included OpenSUSE and Fedora and so on. And so later we will introduce the software page for you. Actually, those software already installed on our demo site. So if you got time, please visit our booth site to reference our software demo. And if you have any questions, you can talk to our expertise. This is the first page of Zephyr. This is the OpenSUSE first page. And this is the Chromium, the running on YouTube. This is open source of Chrome. And this is the LibreOffice that already porting on our systems. And this is another game, personal gaming for your reference. And this is a Blender. This is 3D creation software. And of course, there have one demo we want to highlight is they have a software demo. They run in the OpenAMP with a tiny YOLO. They were demo the hybrid solution for both X45MP and X27V. You can see they will do the image recognition and the image classification through those two CPU cores. They will do the cooperation between two CPU cores to do the image negotiation and classification. And this is the first page of Fedora and so on. So thanks for your listening. If you got time, please visit our demo site. Thank you.
Thank you so much, Mr. Ted Chang, for your presentation. Okay, ladies and gentlemen, welcome back. It's going to be our last panel discussion, and we will be inviting our chairman of our organizer today, Mr. Frankwell Lien, to come to the stage to become our moderator. We also would like to invite our panelists, Mr. Ted Speers from MIcrochip Technology, Mr. Travis Lanier from Microsystem Communication, and also Mr. Stewart-Lu from Metanoia, and Ming-Chi from Chalpes Quantum. Please give applause for gentlemen.
Okay, thanks to the panelists, and welcome our audience, friends, to join this panel. The subject for this panel is RISC-V enable the AI edge everywhere. However, in the beginning, I'd like to have our panelists, each one of them make a little bit introduction to yourself. How about we start from Ted?
All right, yeah, thank you, Frankwell. Yeah, so my name is Ted Speers. I'm a technical fellow at MIcrochip and the FPGA business unit, and been involved with the RISC-V almost from the beginning. I was on the inaugural board of directors starting in 2016, served for 8 years, and been, I think, quite an evangelist for RISC-V, and got our actually company to invest in RISC-V. And it's been a journey that keeps on building. So we have a product called Polar Fire SoC, which is FPGA with a 5-core RISC-V, but then now MIcrochip is producing something called the HPSC, which is the high performance space computer, which is a contract with NASA. But I think And I think we're changing the world with RISC-V.
Thank you. Travis?
I think I already gave quite a bit of my background earlier, but I can do a second round. So I've been doing CPUs almost 30 years. I started out at AMD, was at ARM for like a dozen years, then at Qualcomm, where I was actually there and pushed through Qualcomm to be one of the inaugural members of RISC-V International back at the time. And so I eventually left, and I'm at Ventana now. Obviously, I believed in RISC-V, so I went from doing CPU at Qualcomm to actually pushing RISC-V in a startup.
Okay. Yep. Can you turn on your microphone?
Hello. Yeah, my name is Stuart. Last name WU. Always separate, otherwise people cannot connect together. I've been in the networking industry for almost 40 years, and I've been serial entrepreneur. I sold the company 3 times. Okay, I think the biggest one is I sold to Broadcom. So I used to be the Broadcom APAC general manager. That's where a lot of people knows me about. And back in the pandemic, and the government of Taiwan invited me back to run turn around this company called Metanoia. So we talk about that. What's the connection with Metanoia with AI? Actually, without connectivity, without the cloud server, you can't connect with AI. So that's where I am here today.
Yeah, thank you. Yeah, Min?
Hi everyone, my name is Min. I'm doing the cryptography research for over 50 years. And partner with many universities around the world to doing the standardization for new encryption algorithm for less than 6 years. So we are happy to invite new encryption, 3 new encryption standards just announced on this August in these years. So our company is doing the crypto system design. So help the cryptocurrency company, blockchain company, and many enterprise, help them to protect their very confidential data in the database. So our company also the PQC promotion chip innovation in the chip innovation project in the Taiwan. So we partner with the Ministry of Digital Affairs to have a 5-year project to promote PQC into the industry. So this year we are first years, and also thank Frankwell also supports a lot. I'm happy to connect with RISC-V ecosystems and to help more companies can adopt the new encryption standards. Thanks.
Yeah, security for AI device, right? AI edge. Okay, I have one slide I'd like to share with all of you that we can initiate the panel. Can we have that slide on? Yeah, here we go. In fact, this was on my presentation this morning, but I like to describe this slide in another perspective. We all know RISC-V has been successful in deep controlling application, some microcontroller area, DSP vector, and so on. So what is the position or the profile that RISC-V can enable AI edge is the subject. So let me start with that. In the beginning, I like to initiate the first round Q&A from the definition of AI edge or RISC-V strengths for AI edge. I like to highlight that this morning we have a panel for AI, so we need to make this panel a lot different from that one. Okay, may I start from Travis? What is your perspective on definition or the strengths of a RISC-V for AI edge?
So Edge is a nebulous subject. We could probably talk an hour trying to nail down exactly what the edge is. But I think most of us agree that it tends to be something that's not in a data center. Generally, you're going to be more power conscious, but again, that can mean from milliwatts to still, 50 to 100 watts. But it is something that's meant to be out and about and not necessarily in an enclosed environment. I also tend to rule out automotive from that. But to talk specifically about RISC-V for the edge, what makes RISC-V, it kind of goes back to what I was saying earlier, and well, all of us have been saying, is that because edge has that power sensitivity, that's where RISC-V has the strength. And so you have this domain-specific acceleration so that you can customize it and get the best power, performance, cost efficiency, and hopefully, as we progress on the software front, most flexibility to deploy on these various edge devices.
Okay, how about you, Ted?
Yeah, try and add something to that. So, yeah, definitely outside of the data center, definitely power constrained to think about. So it can be thermal or it can be total power. I think where we fit is in the thermally constrained. So we like to say we're going to put fan companies out of business. Other thing, I mean, security is important. So edge is exposed hardware. We say there's no guards, guns, or gates protecting the hardware. So security is an important aspect of the edge. And then finally, edge is, you've got a lot of human machine interaction. So I think safety, reliability is another aspect of that. So RISC-V can kind of, I think, is poised to kind of address all of those. So.
Okay, so power efficiency, small device, customization, and security are the factors I heard so far. We invite Stuart. Stuart's company is doing infrastructure for HAI. So what you see from that perspective?
If anybody knows work in Broadcom back in 2000, Broadcom used to be the powerhouse for MIPS CPU. I was the one actually pushing very hard for ARM. So because I was building the CP device, so-called your home router in your home. And now I'm actually very opposed of the ARM. Why? It's because openness. In Metanoia, we believe openness, open source. That's really the key for any company to be successful, I say, moving to the future, especially for the small company want to get the bite of the market. So working with NDs, especially RISC-V, the key is not only the configurability and also the cost and power, but the most important is the open source. If today you work with a company like ARM, you have to take order from whatever they can give you. But working with NDs, you can customize what you want to do, and you can open source your software. So today, if anybody, my system customer, if they want to work with us, we give them full source code. Okay, we release full source code to them. Okay, and so this is very unique. And if you work with Qualcomm or MediaTek, no way they're going to give you source code. So this will be our biggest advantage, and also biggest advantage working with RISC-V.
Good. From security point of view, what do you see? Min?
Yeah, for AI age, for my definition is devices can control and taking action for some very important operation. For example, I participate in the drone design in Taiwan, some projects, and this kind of devices have ability to doing some physical attack and doing some mission, for example, cleaning or to analysis on the sea. So for my point of view, AI age need be very careful to design their security from security boot, disk encryption, authentication, and identities. And for compared with on ecosystem, RISC-V offer more controls on security features can let you combination different kind of feature into your devices, which means for our technology, PQC also very innovation in the market. So RISC-V can give us a new instruction set and accelerate our new algorithm operation that will benefit security a lot. So thanks.
Yeah, I think overall we heard the advantage of RISC-V, that it can enable AI age, also the definition of AI age. Now, in terms of the value chain of AI age, because we are from a different segment of our supply chain, value chain position. So what do you see from the past experience till now? Any successful story, or do you have a product offering for AI age from your company? And how do you segment your product to leverage AI age trend? Yeah, I'd like to have Ted speak first.
So, I mean, all those attributes I mentioned, low power, security, safety, reliability, are happen to be our FPGA attributes as well. But RISC-V, to me, was the thing to leverage, is kind of the missing piece. We always, when you're trying to innovate, going to ARM, ARM's a great company, but it was like going to the optometrist. You like this one, or you like this one. You can't, unless you're Qualcomm or MediaTek, you can't get them to make what you want. So with RISC-V, you can go and optimize exactly for your domain and application. So that's the success story for sure. And then, we talked about stepping in and developing a part for NASA, which is the edge of the atmosphere, low Earth orbit. So, we got a number of success stories at MIcrochip that depend on almost all aspects of what RISC-V offers.
Great. Metanoia also provide 4G or 5G infrastructure to the industry. So I believe that is the infrastructure for AI age to enable its application. So any story you would like to share with us?
Well, actually, Ted just kind of continue what I just said. The openness, open source, made to order is really the key differentiator that why company like us want to work closely with RISC-V. This is almost like positive feedback, right? So if we have something, we give feedback to Frankwell and Charles, they will make their system better and give back to the total society. So this is I think this is really the industry trend. That's why that working with RISC-V is very comfortable. And also that today we are building the infrastructure chip. Doesn't mean that we will not put the intelligence onto our chip. That becomes an edge AI chip, because we are building. I don't know how many people know that Metanoia is really a proponent for Open RAN, stand for ORAN. And ORAN, we are building the last mile device. That means the radio unit. And we are trying to commoditize, disrupt this market with our radio unit circuit, which will drop the system cost for the RU, not 50%, not 75%, but 90%. That means whatever system they are building today, if it costs $10,000, it will drop to $1,000. If they're building today is $1,000, I will drop it to $100. Okay, that's our mission. And that's why we think this will be very disrupted. And also working with RISC-V, we talk about it, power efficiency, low cost, openness, configuration, made to order. This is all the advantage of RISC-V you can work with.
Great. I think your mission will soon become a successful story.
Hopefully, with your support.
Okay. And will you leverage the trend of RISC-V over AI-H?
Yes, as I mentioned, I joined 2 different projects. One is for medical devices. The other one is for the UAV. UAV is ongoing. Hope it can be successful soon. The advantage why we choose the RISC-V. First thing is, it's open. Most of design we can find in the communities. Compared with we have touch base with Qualcomm and the other companies. Once we want to know more trust zone design and their key life cycle management in the chip, okay, they say, oh, please subscribe 200K as a first membership fee first. Okay, for staff is huge money, so we start to seeking the other solution. So for the community support, we always can find partners. They have meet the similar questions, and we also can contribute our result into the community as well. So for cryptography design, and we also trust a similar idea. Our company joined Linux Foundation for 10 years. So we are the main contributor for open source library for PQC, and we'll release the final version in next years. So after we doing a lot of design and contribution in the open source communities, actually we will grab the attention. For example, I have a few customers from Europe. They see our paper and see our commit and then find us. So go back from strengths of RISC-V. In the UAV, you need a lot of I/O to process different sensor data. For example, camera, you will have 5 or 8 cameras you need to deal with at the same time. If you're using the other CPU, I think I can't use to solve this kind of solutions. But RISC-V have a possibility that us can deal with new to making a new solutions with this different kind of combination on technologies. Yeah.
Okay, good. Why I mention value chain? Because here we are in Taiwan. We know in terms of a population, the end users number in Taiwan is not many, you know, comparing to other region, countries, areas, Taiwan is rather small, but the industry is kind of down in the, from the top to the downstream of the value chain. That we represent quite a lot in Taiwan. So from your company, do you plan to leverage or do you plan to, you know, promote your product for AI-H to Taiwan? Do you have such a plan or experience? Can you share that, Ted?
Yeah. When you're training, you're asking what could RISC-V do for Taiwan? I thought afterwards Taiwan could do a lot for RISC-V if TSMC offers 10% discount if it has RISC-V on there. So that's just my idea there. It's an interesting question. You know, first of all, RISC-V is important for technology independence. So every country should be having a RISC-V strategy. And kind of, you know, what's new, I didn't think about this too much when we did the practice run, but, you know, I've been here just today and yesterday. You know, there's met a couple interesting professors who are doing some great stuff with the RISC-V, have a big, pretty good image or vision for a lot of interesting areas, and I would like to, you know, connect with them, and hopefully MIcrochip can help. I know Andy's is doing a lot here with the universities, but, you know, MIcrochip has you know, we're first company with real product offerings out there actually. So I definitely think, you know, us working with the education in Taiwan is an interesting opportunity for us.
Travis, how about you?
Well, we're focused on making server class products, but as you kind of touched on, you can't really make a product without somehow touching Taiwan, right? And what's great about working with companies in Taiwan is you have everything located here. So if you want to actually innovate on the silicon, you kind of have to understand the system and how that gets deployed. And so if you want to do that, you need to be working with companies in Taiwan to figure out how do you put that motherboard together? How do you build that rack? Of course, your silicon's probably manufactured here too, but then how do you quickly iterate on that? So the knowledge on how do you put together these final systems is actually here in Taiwan. So that's what we're excited about being here and working with various companies.
Okay, thank you. For Stuart and Min, I'd like to change a little bit with the question. As you are in Taiwan, so I think your answer is yes, but do you think, are they ready? I mean, down the value chain, OEM, ODM, will they take RISC-V for AI edge?
You know, I think it's obvious because I was from Taiwan. Me, Frankwell, and myself actually know each other since school. Do you know that God created the world very, very interesting? If you really look at San Francisco and San Jose, I don't know how many people knows about Northern California, and Taipei and Hsinchu. And in the middle, San Francisco has a SFO. In Taiwan, there's a Taoyuan International Airport. And then there's a Highway 101 for San Francisco. There's Highway 1 for Taiwan. And in between, there's Highway 3 for Taiwan to Hsinchu, but there's a 208 and Sydney Drive. And the distance is half an hour, half an hour. Half an hour to airport, half an hour to San Francisco, to San Jose. Half an hour from Taipei to Taoyuan, half an hour Taoyuan to Hsinchu. Why is that? And Taipei is metropolitan, San Francisco metropolitan. Silicon Valley, Hsinchu. It's natural, okay? God created this way. So that means Taiwan will be prosperous into this future world. You know, there's no doubt about it. This is not a joke. This is actually, I don't know how many people sense this. The second thing is really think about it. I've been entrepreneur for, as I said, through my whole life, since 1997. I used to base in US and come to Taiwan. And I really, not until 2 years ago, almost 3 years ago, I spent most of my time here. I really recognized the ICT world is so much powerful, okay? Especially for me as a Taiwan native. I can really leverage, for example, I can pick up a phone, call my friend, call Frankwell, call anybody. I get the greatest support. Not only the cost, but also technical support. I know Charles since 20 years ago. I know Frankwell for almost 40 years now. So not to say the Cadence Synopsys, right? And also TSMC. And now, at the same time, when I work with all the OEM, ODM, whether my system company, whether it's Arcadian, Pegatron, Compal, anybody, I pick up the phone, I know all of them. And they also love to work with me. Why? Because I don't have any time zone difference. Any problem come up, my engineer can solve it within the half of the day. Okay, maybe within the hour. They have a problem, they come to our office. So Taiwan ecosystem is really about cluster effect. I don't know how much you know. We used to joke about it. In Hsinchu, you can own a motorbike. From day to night, you can have one silicon completed, right? From silicon die to TSMC, to big company like IC Design House, to package design for testing, then the OEM, ODM, all within almost northern part of Taiwan, all within an hour. Who can beat it? No one can, okay? So, and also now with NDs, with RISC-V, I think it's even with, we talk about it, openness, openness, openness. Even when we are doing open radio access network, ORAN. So embracing openness, embracing the ICT world in Taiwan, I think that will be the key to success, at least for Metanoia.
Oh, this is interesting. Ming, would you like to add comment?
Yeah, so Taiwan definitely will be the great place. Can let RISC-V become the next majority chip platform. Taiwan have government allocate 100 billion, 10 billion USD dollars for 10 years to encourage chip innovation. That can compare with the other states or countries. I think no one will put these large monies to encourage the industry find the next up. So yeah, let's have a possibility, have a 10% off in the TSMC. Yeah, but yeah, we need to
15 now, I think.
Okay, yeah. So and Taiwan do not have any natural resources, so the people here is work really very hard and care about their outcome to customers. So this kind of thing let the place in Taiwan can keep tracing the next generation innovation around the world. So you can see most of AI server is from NVIDIA, now is made in Taiwan. That can see if any chain is going to the mass production. Taiwan, ODM, and the entire ecosystem definitely will put very hard, maybe 3 times compared with the other countries to make the things happen and always keep the reasonable profit every country to every partners and consider long-term partnership together. So even you know China was a very big manufacturer base stations. That's all built from the Taiwanese the entrepreneur to let them know the new things and training them. So this end of month, because June they want to a new supply chain. So U.S. government also see Taiwan is a very key players in the futures can support become the largest UAV manufacturer place. Yeah, so combine lots of things. I think Taiwan will be the best place to let RISC-V and enable AI solutions, not only on server side, but also in the edge as well. Thank you.
Thank you. I think, thank you, you all that answering my 2 questions of are you ready? My first question was, are you ready, Taiwan OEM, ODM? Now you give a positive answer. Now I'm going to ask another round question, which is another, are you ready? Are you ready, RISC-V? Are you ready? Back to the panel subject. RISC-V enable AI edge everywhere. Is that true? Is that a vision only? Or is that a challenge? To what degree we already achieved that? From your observation or your preparation, what is your answer? What a challenge you think there will be for this subject? I'd like to hear for that. So this time, let's have Stuart start.
If you know that back in the old days, when MIPS was very powerful, why it's powerful? Because we have an ecosystem. When I push ARM into Broadcom, back then now called Avago, they also was very high resistance because there's a lot of IP has been built around the MIPS. Okay, it's the same thing today. Okay, ARM really they leverage with their ecosystem, right? But however, when you come to the edge, you don't need to have such. You don't need to be tied to such ecosystem. And also, once you embrace the open system, open source, open concept, you don't need to be tied to ARM ecosystem. That means RISC-V can have very great potential to be successful because the key differentiation of RISC-V, the reason they come up is because openness, right? Because open source RISC. That's actually, at least that's what I understand, right? So I think this key is very simple. It will be the key. I think by the way it accelerate, with more adapter, with more people see the differentiation, eventually I think looking upon in 10 years, RISC-V will be much bigger than ARM. Why? You look at today. Well, if not more, it will be equivalent. You look at the server market. Used to be no Linux. Now it's everywhere is Linux. If you guys remember, there's an old company called Sun Microsystem. We used to want to buy their workstation, FT price. What happened? PC plus Linux replaced all. So Sun, luckily, they sold it to Oracle. There's no Sun. So I can, some company can make money for the short term, but its long term, its openness is really the key. Because you have the open community pushing for it. That's really the big force.
Well, thank you. Openness, open community is really the key word. RISC-V is an open standard. Thank you. Min, from your point of view, can you contribute?
Yeah, I'm more on application side to see the RISC-V ecosystems. From my point of view, yeah, it's still growth. So for customer, if I want to buy a chip to, for example, on the drone, I ask many drone manufacturer company, oh, do you see any problem on the M4? They say maybe no, they are great and they're very cheap. So, and I ask them, do you know the RISC-V? Most of them do not know it. So, which means the supply chain on the RISC-V is not ready yet. So, but it's still growth. But I think I have confidence that if the AI age, some of ODM company, they are starting to have more cost-effective benefit on their devices, try to replace more components in age, not only on the AI, but any kind of automotive or the other devices, even PC, and build up the mature supply chain. The RISC-V definitely will be the biggest in the futures.
Thank you. Travis, yeah, I think we are eager to hear from you.
Well, I think you already know that RISC-V is pretty much already taken over microcontrollers. So it's hidden, but you can look at how ARM got started. They were a microcontroller company when I got there, right? So I was there when they first booted Linux. And so it comes down to volume, how many people are using it, how much are out there. And if you look at how quickly RISC-V has scaled the microcontroller space, it's mind-blowing. Then you were showing graphs this morning where it was showing the number of AI applications with RISC-V taking off. So we have one pillar done, microcontrollers. That's almost a given at this point. And then you look at this other thing that's coming that didn't even exist at the time ARM was taking off. You have AI. And we've talked this to death this day, but I think we all agree that A, if you're going to do AI, it needs to be open. But B, it helps to have a standard that you can build off of. And that's a unique thing that RISC-V has. And so that is going to accelerate the other pillar of RISC-V taking off. And then you're going to fill in everything else in between. So, you mentioned servers. Obviously, I'm very keen on that happening in the next couple of years. And people keep saying, hey, when's the high performance going to happen? I know I'm venturing a little bit out of edge here, but you're going to see it go into all these segments over the next couple of years as we move beyond the RISC-V space. And a lot of this will be powered by AI.
Great. Will that be too positive? Ted, have you objection?
What's the question?
The question is RISC-V enable AI edge everywhere.
Yes, I think so.
True now? or there's
Yeah,
a
so I think
challenge?
there's obviously challenges. We should have, if I was speaking for RISC-V, yeah, it's not over by any means. There's a lot of work to be done, but I mean, there's nothing in our way. So the ecosystem does, if there's silicon there, the ecosystem will rushes in there to fill that. I hope that gets proven when we get the HPSC out there and everyone in NASA is doing all their missions, which includes, of course, AI. But I was struck, all the talks today were pretty interesting, and there was mostly alignment, and everyone was like saying, at the end, we need these tools. But everyone was kind of coming up with their own vision of how those tools are to come together, and I think there's opportunity for the adopters of RISC-V to maybe work, and so that tool at the top is uniform, so one tool can target any DSA that anyone creates with RISC-V. I think that's what everyone was kind of saying. That's certainly what I was saying, but everyone, it can't be 50 different ways to do that. It's got to be one way to do that.
So keep building ecosystem, solution providing, and the whole, the community keep working together. It's like what you said.
Community has to keep working together. They had all these people work at RISC-V together and started the business, and now they shouldn't be fighting with each other necessarily. We should be still collaborating to win the war. Just because we won the first few battles, I think we got to stay focused as a community.
Yeah, very nice. I'd like to, borrow what our panelists, especially Ted said, keep working together as our conclusion for this panel, but not just not yet. We have Q&A session. So how much time we have? We have 5 minutes. So perhaps we can welcome 2 to 3 questions. We have a microphone ready for you. Oh, okay. Okay, let me count down from 5. Okay, here we go.
Yeah, thanks for the good discussion. Just on the topic of edge AI devices, are there any available edge AI devices powered by RISC-V chip that's available on the market or off the shelf?
Okay, let's start from me and backward here.
Our solution is ongoing to design. So, but when I doing the search on the markets, it's true do not find the spec I want. So, yeah.
And yeah, Stuart.
Our current system not yet based on RISC-V, but we are taping out the RISC-V based chip by October. So hopefully early next year you will see all the system vendors using our solution. Remember, I said I want to disrupt this market.
Okay, Travis.
We'll be sampling our systems next year, so we don't have any out right now.
All right. Yeah, Ted.
Yeah, NVIDIA GPUs have tens of RISC-Vs in them, so. But yeah, MIcrochip, again, we have a product called PolarFire SoC, which is a RISC-V processor embedded with FPGAs that are very low power, very secure, and yeah, we're winning with that in edge markets. And so you can use the processor to kind of run your application, but then the FPGA is a good way to do your AI acceleration.
Okay, thanks. Even though I am moderator, I jump out to say, to answer this question as well. Allow me. We find that there are customers designing earphone audio box for AI audio processor. There's a customer doing IoT doorbell. There are customers doing a drone video processor and the controller for drone itself. And there are customers doing a language translator. So I believe these are all AI-H. Other than that, there's a customer doing a PCIe-based AI accelerator. That is also one of the application which AI-H really means, boost the computing power for AI. We also see customers do AI wearable devices on the way to the market, and also ISP for video camera with RISC-V is an AI device, AI-H, and AI inference chips for mobile devices. That's from my contribution. So any other question? We can, okay, there's one more here.
Hey, thank you. That was a wonderful discussion that we have today. So my question is related to the security, like the cyber attacks which are increasing in the world day by day. And since this is an open source, the penetration of mobile phones or internet banking, mobile banking is being there, and the IoT devices as well. How do you ensure that in the coming times the security issues have been taken fully care of, and there are no problems in using the RISC-V as an open source? Thank you.
Thank you for that. Because your main product is security, so we let you answer first.
So in security industry, more open is relatively equally more security, because we will be analysis around the world. Everyone, if find some issue, they are very happy because they can write down a paper and get a word. So for security on the public domains, I think code can be evaluated by yourself. And in the security ecosystem, we also have a lab, and a series of company can serve you. If your product after you met, we can give you a white box analysis, black box analysis, and doing some situational attack analysis. A lot of testings behind we can help the product owner to do. So I think after the product analysis, you can see, okay, lab have a baseline security. And then we need to keep the agility on your products. Once your product goes online, any issue be potential funded, the only way is you can find a way to doing your system updates, OTA in soon. So I think that's a new platform. Open source should have a basic spec, and then you can keep doing your business in the futures.
I want to just make maybe a counterintuitive point here, and maybe it doesn't help an individual vendor, but what you have today is a monoculture. You have either Intel or ARM, and someone comes up with one attack against those things, and the whole world goes down. So with RISC-V, when you've got competing ecosystem, the fact the world will be safer if there is not a monoculture of devices out there. So that's a very high-level system view of why RISC-V is going to make the world safer.
Yeah, especially introducing Ted Speers. He has been serving as a board director of RISC-V for more than 8 years. We have to thank his effort and work result. So today we can see RISC-V up to this successful stage. Beyond that, I'd like to address also on this question that in terms of RISC-V International Association, it has been requested since day one, what is the countermeasure of RISC-V toward arms trust zone. So RISC-V International really spent effort. Its members like Sci-Fi offering WorldGuard and Andy's offering the solution of IOPMP. Those countermeasures are, piece by piece, like puzzle assembling. We look forward to see them, getting ratified in RISC-V International Association, so that the whole RISC-V ecosystem can have a true and effective countermeasure to arms trust zone. So still, we know clock ticking, right? But yeah, it will be here soon. Thank you for this question. Any comment?
There's, in security, there's two types of security: static, dynamic. Static means trust zone, and then you have to work with a secure boot, right? Because when you system boot, you want to make sure you go to this secure zone, and then you get your, whatever the OTP, your key, and you boot it. Before this being verified, then you boot the main system. This is called static security. In our world, communication, we have a dynamic, that's crypto, that's a VPN. Okay, this is actually not part of RISC-V. This will be part of the RISC-V's ecosystem. There will be somebody building the security processor to go along with the RISC-V. So RISC-V will have a peripheral connect to it. So I think this is something when it will almost like whoever can work with the ARM can also work with RISC-V. At least this is my understanding.
Thank you. Okay, our time's up. I think more than 3 minutes now. So let's wrap up this panel. Again, I'd like to have your big applause to thank our panelists. And thank you all.
Thank you so much, Mr. Frankwell and the panelists. Please stay on the stage. We would like to have a picture together.
Thank you.
Okay, stay on the middle. We will have a picture. And after this, we will have a lucky draw. So everyone, please come to the stage. Okay. See the camera. Have a big thumbs up. In 3, 2, 1. Okay, and on behalf of RISC-V, we have a final pose, V for victory. In 3, 2, 1. Okay, I guess everyone is already excited, but unfortunately it's going to come to an end. Thank you all for joining us today. I would like to give special thanks for our sponsor with our prizes and partners who joined us to our exhibition, and also to provide the RISC-V products and innovations. Now, once again, thank you very much. Please feel free to scan the QR code for you to join our RISC-V Taiwan Alliance to say the updated. And also, on behalf of RISC-V Taiwan Alliance, we wish you a wonderful Midterm Autumn Festival. RISC-V Taipei Day, see you next year. Thank you.